Yeah, just be careful that the edge of that yellow card there with the lens. I can't see where the other where the other camera is. Sorry. The problem is I can't see the far side. That's the, yeah, you just have to make sure you're clearing it along that left edge of my camera as you're going down. See, I think you may be hitting it. I mean, frankly, it might be easier to do this. Can we just carry it to the stadium like this and then deal with the weights there? Because I think that then we're going to get rid of the tide gauge there, and then you won't have that complication. I think that's a better idea.
Okay, I've set up the YouTube stream.
Great, thanks, Ross.
And I put the link into the chat, and I'm hoping that the captions are going to show up in the YouTube video shortly.
Okay. Just a little bit west of Stadium. No, we want to put it down at Stadium. There is a bench. There's actually, we're going to go to benchmark number 3, which is right. You know, it was just a few meters, 5 meters from Stadium, because I'm going to want to put the tide gauge and the current meter right there by benchmark number 3. You want 5 meters away from benchmark number 3? The elevator, sure, that would be fine. Hey, Ross, if you don't mind, can you send CL the YouTube link too?
Yeah, sure.
So she can pass it on to the family. Thanks.
So just so that you know, the captions are showing up in the YouTube feed. So that appears to be working. And I've opened up the chat in the YouTube feed, so anybody can comment and chat on there. So we'll see how that goes. The biologists were using it with great success yesterday.
Yeah, great. They had a great dive. I think they were excited to use the Zoom feed from the ROV. So I'm glad that they did, and it was very useful both for outreach to students and family and friends and the general public, as well as for their collaborators, Sean Arellano at Western Washington University and Costa Vitriani at Rutgers. So yeah, I think that they really liked doing it, and certainly they were looking at a lot of very cool or hot images of the vent animals for most of the day. So people probably got too burned out looking at all of the vent communities, but they were definitely seeing some picturesque sites. We're going back to that site to do our fluid sampling, so we'll be setting up there in a bit after we take care of some of this housekeeping of deploying the tide gauge and current meters and whatnot. So we're on our way now. No, Ross just sent it. So yeah, Ross, will you copy me on that so I can forward it to all the folks here on board?
Of course, yeah. It's also in the chat here, but I'll put it in an email right now.
Yeah, I have the computer, my laptop that I'm using for this. I expressly didn't deal with my mail and whatnot because I didn't want to complicate things for everybody. So I can't easily communicate when I'm up here in the van. But I'll go downstairs in just a second and I can forward it on. But if you email it to me.
Yep, I'm doing that right now.
Thanks so much. Thanks for all your help with setting this up and navigating the complexities of the modern world here with social media.
And it's the least I can do.
But I think, well, it seems like it's been very successful, and I think that I think there's a real opportunity here for us to provide NSF not only with feedback, operationally about how it worked, but for them to, be considering this for future cruises. I know that they've had a lot of internal discussions about it. That's certainly what Kevin and Jim Hollick have said. So it is something that I think they view as a bit of a wave to the future of how you can involve and engage people more in oceanography, as well as to involve shore-based collaborators that for whatever reason can't come out. And certainly that's been the case here during the pandemic when it's been so challenging to get a lot of people out to sea. So Mario, you're basically going to ride the inner donut north and then turn a little bit to the northwest. Great. Okay, that sounds like a plan. And Tito's got the ship moving, right? Great. So did you guys ever test my down-looking camera?
Sure did. You want it on?
No ground or a ground?
It's at a ground.
How much? That's not bad. Let's run it. At what altitude are we at? Okay. Can you come down to like 8 or something like that?
The vehicle's trying to maintain 18 meters altitude.
Oh, okay. Well, then turn it off for now, and we'll turn it on later on after we get rid of the elevator. But at least it works, and the ground is not as high as it was before. I mean, I serviced all the connectors on it. Yeah. No, it was 0.7, I think, is what I was told, right? So I serviced all the connectors to both the strobe and the camera. There isn't anything else where it could be not easy. I mean, my connectors are easy but not. Yeah. Okay. I mean, I did that when I looked through them, and they're all sort of hidden away under the ROV. So I would. Yeah. Yeah. Okay, the ship is moving up to the northwest to get back to the benchmark 3 site, which is maybe 50 meters or so northeast of Bio 9 vent. That's been our sort of staging area for a lot of equipment. And Jason Sullivan at Texas A&M had his experiments out there. Charlie's advisor, Charlie's here on watch. The watch team here is Charlie Holmes and Keldon Peer and Sam Bozen. Keldon and Sam from Lehigh and Charlie from Texas A&M. And I'm Dan Fornari from Woods Hole Oceanographic. So we've got about 75 meters to go. We're up high because we're carrying the elevator, and we haven't been able to get any of the weight off of it yet because the tide gauge is sort of in the way. But we're gonna get that out of our way as soon as we get there and get positioned, and we'll deploy it at the Benchmark 3 site. That Benchmark 3 site was established in 2007 when we were here with Jason. That was after the last eruption in 2005, 2006, the volcanic eruption that is the most recent one that's occurred in this area. And at least part of our work is based on studying the evolution of the hydrothermal system and mapping the detailed characteristics of the seafloor using Sentry, so that when the next eruption happens, we can have a very quantitative assessment of the amount of lava that came out, where it came out, how it came out, and all of that. Okay, the vehicle's now turned to the northwest and heading directly to the stadium area. Got about 50 meters or so to go. So if you get right up to stadium and Benchmark 3, we really want to put the elevator quite close, 5 meters away. Yeah, so we don't have a long way to go. And it's pretty good terrain. There's low baits there, pretty solid, not too many collapses. Got about 30 meters to go, so it should be coming into view. You okay? What's the matter? Oh, already today? Well, that's why I put mine down here, so nobody can see it. Sorry, we'll deal with it. Thanks. Here, I got it. Kelvin, you want to hold that? Okay, you're just about there. Okay, that's good. Let's go down slowly and scope it out, figure out where they are so we don't drop this right on top of them, and then we'll get busy. Yeah, that's okay. That's the benchmark right there. So I don't see bottom, but I see the benchmark. Oh, right there. There you go. So go a little bit forward. Yep. Seeing just in the top of the screen, the benchmark that we made. High-tech milk crate and plastic cutouts, but it works. Filled with pieces of basalt to weight it down that we just happen to scoop from the area right here. Okay, I would say let's stop here. And if you can put it down so that it's oriented, you see the light pointing right to there. Let's orient it so that it's looking directly at the benchmark, and we'll probably turn the lights on and have it film you working it right at it. So you might go, okay, so now I'm seeing a collapse off to the left, so you might want to move right just a little bit. Is it landed? Okay, well, I guess that's it. Good. Yeah. Yeah, sure. Right, that good. That's good. Right there is perfect. That looks great. Thanks, Miriam. All right, look at that. Great placement. Okay, so let's go around to the left so you can turn the lights on, and then you can get the tide gauge and sort of proceed with whatever you're doing, and we'll hopefully catch some of that on the imagery. And I don't know if you've manipulated these switches yet or not, but you rig the bungee, so you got to get both bungees off, and then just slide the ears of the switch to the left, and that'll turn them on. They've got a detent at the end, so they'll stick at the end. There's two of them. Yeah, there's right there one, and then the other one above on the green frame. You take a grab of that? Oh, I can take a grab of that. Yeah, that top yellow loop is the bungee. That's it, and then up and over. Perfect, that's good. And then just grab the other one and push it forward. And then all the way. You might just give it another shove with your fingers. I can't tell whether it's not on yet. There's a detent there, so yeah, just give it a shove with your closed fingers to the right. Okay, that's good. And those should be the top lights are on. Yep, that's fine. Okay, now the green one is the bungee is the bungee loop. That's good. And then the same for that switch, and that's the lower lights. Okay, and just there you go. The detent just took. Okay, great. You got the lights on. All right, now let's go and face around to the right, to the tide gauge. There's 2 pull pins that you need to take out, and those bungees will come off, and we'll lift that and we'll go place it right next to the benchmark. So somewhere in the menu for C-Log, there's when we're dealing with instruments, I can't remember if we had one for tide gauge. We may not have, but just make sure to mention it. Okay. So the batteries, the lights on the elevator are made by Deep Sea Power and Light in San Diego, California. Longtime collaborator with WHOI's National Deep Submergence Facility for Alvin and Jason for imaging systems and lighting systems for deep ocean vehicles. The camera housings that are on there are also made by Deep Sea Power and Light. Longtime collaboration between Mark Olson, the president of DSPL, and myself over the last almost 25 years. The 2 cameras that are on the front of the elevator are taking 4K video. That's the top one, the cylinder-like one that you see there. And then there's another one in the front that is taking 12 megapixel still images. And it's doing so at a rate of one image every 5 seconds. Those are camera systems that were developed by me and Eli Perrone at EP Oceanographic with funding from NSF's Ocean Instrumentation Program. Jim Hollick is the program manager for that. And the cameras are operated as part of a facility at Woods Hole Oceanographic that focuses on deep sea imaging and sensing technologies. High temperature loggers that were going to be deployed similarly were developed at WHOI with Eli's collaboration, and is a commercial product that his company EP Oceanographic in Pocasset, Massachusetts on Cape Cod produces. Okay, so those 2 loops, pull them to the right. They both go off to the right, and the bungees will come off, and the tide gauge, I affectionately call it the hedgehog, will then be free to be pulled up and out. It's got 4 feet that are just sitting in that cutoff milk crate. There's one. Yep. Eventually, I will. I'm not so worried about this stuff. Those colors are actually pretty true. So Mario's just now going and putting the cotter pin someplace in the back of the basket. There's a whole lineup of them in the Jason control van. These are reusable, and we don't like to leave plastic on the seafloor. So he's stowing that in one of the milk crates on the basket. There you go. Number 2. And then you can just pick it up with that bail, Mario. The blue, yeah, the blue taped bail, and it should come straight out. Feet are pretty stubby. That maybe, I don't know, 6 inches or so. And then, I'm sorry. Yeah, well, we will. That's great. And up and over. Can you start? Okay, there she blows. Very good. Okay, Mario. So if you could now drive slowly over to the right, and because you're going to be going in front of the camera, can we turn off the the starboard lights? Keep the port lights on, but turn the starboard ones off. And we'll just try to find a flat place there, right near benchmark 3, which is perfectly positioned. You did a great job, Mario. We're looking straight at it. So if you can come around to the left and then just be angled this way when you're putting it right, perpendicular. Yeah, perpendicular to the cameras. Right. Okay. All right, so here we go. We're on our way over low bait lava flows here at benchmark 3. This is just up and over the axial trough wall, the eastern axial trough wall, just a little bit northeast of a Bio 9 vent, where we have already sampled fluids and instrumented the vents. In Bio 9, we have both a logger in the central orifice and in the southern orifice. Right, and if you could stay, you need to be like right down on the bottom when you're doing this. So before you go any more forward, come down. Yeah, no, that's fine. I have the camera pointed up a little bit, but I think right like this should be great. All right, so we're approaching benchmark 3. We have 4 of these benchmarks up in this area that we deployed to serve as navigational aids. Well, it's got 4 DSPL 5150 C lights on it, so it's probably 4 times. It's got 36,000 lumens. Okay, that's good. Yes, try to find a place. You can see those 4 feet. So let's nestle it someplace where hopefully it won't rock too much. And so maybe like right here or something like that. Right in front of the milk crate. Let's just sit down. So all the starboard lights are off, right? Thank you.
Well, the lights and stick are on and they're facing directly towards.
No, you have to turn those off, like right now. Can you, yeah, so lights on the stick are off now?
Lights on the stick are off.
Okay, good. Okay, so right here, let's just try to set it down. Okay, Mario. So let's give that a try. I'm thinking, you know, it would probably fit right here, right next to it. Can you do that? Right, you know, just to the left side of the basket. So right there. Okay. That's great. Okay. Looks good. Does it look like it wants to slide down? Can you maybe shove it?
You see the blue loop
Yes.
kind of easing the arm off so the blue loop goes slack. You know,
Yeah. 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 I think you want to push it back. I think you want to push it back that way. And into the screen, diagonally away from you. Yeah, yeah, because I think we're on the top of that pillow or that low bait, and the feet are wanting to slide down it. So you want to try to hook the feet over the other side. Yeah, right. So how's that look? Yeah, good. Okay. All right. That's fabulous. Excellent, Tito. Sorry, Mario. All these names ending in O. Okay, great. You can stop the clip. Okay, we've deployed the tide gauge right there. And now you have in the basket a current meter. So there's two of them there, just pick one. And I'd like that over here. See where my pointer is over here? In that, nestled in that little crack between the yeah, two pillows so that it doesn't go anywhere. In the black bio box. And you can pick it up by the syntactic. Oh yeah, there they are. They want to go. They want to go on the seafloor and make measurements. All right, just pick one. Doesn't matter which one. That's great. So that's going to be 823. Yeah, you pick it up. There's also the serial number on the body of it. You got it. That's it. Okay, up and out. It's got a lead weight on the bottom. Just let us have a look at the number. Yeah, so just hang on a sec. Yeah, you got it. Okay, so 1 sec. Let me just read that number. That's a. Can you just twist your wrist just a little bit so I can read the serial number? Okay, 823, 201, 823. Okay, current meter, TCM current meter, 201, 283. Sorry, 201, 2823. Got it? Right, 201, 2823. Okay, all right, that's going to be placed here at benchmark 3. Do you think you can reach up there or not? Or if you want, Mario, just rotate left a little bit and we'll see what space we got here. Yeah, just rotate to the left. I'm guessing there's probably a similar crack in the interstices between the lobates that you can nestle it. Oh, you can? Oh, with that arm? Oh, okay, sure. If you can, then sure. It's a bit deceiving looking at the screen here. But if you can, then just put it right there and that'll work. Yeah, you could probably come, elbow out a little bit more to get it further in there. Yeah. Yeah, like right there. I think so. Let's let it go, see what it does. Okay. I think that's a winner. Okay, they can keep each other company for the next year until we get here on our next cruise. Very good. Nope. You're gonna get that other current meter and put it in your manipulator, and we're gonna fly into the trough. And the question is can you close the box then with the other manip, or you don't want to do that?
I could grab the current meter with left minute.
Sure, fine, perfect. All right, we've got the current meter deployed here and the tide gauge at benchmark 3 site. Just going to do some housekeeping and get this other current meter, which we're going to just hop into the axial trough a few tens of meters to the west of here and place that at a good site in the axial trough. And then we'll, there you see the manipulator gripping it. And that way we'll have it primed and we'll close this box here. And we don't need that opened until we start to deploy the high temperature loggers, which you see in the down in the box. You can just see the metal tips of the high temperature loggers sticking out of the front of the basket. Okay, we're good to go. So as long as we are here, can you, Mario, turn off the rest of your lights? All right. So from where you are now, can you come up slightly and go back, and then just fly towards the elevator? Yeah, just a little bit, not very fast. Everything's slow. Do the samba. And you could leave that butt light on if that helps. That's fine to leave it. No, you can leave it on. It actually probably would be cool looking. Okay, so yeah, just come up a little bit, not too much. Yeah, probably like that is good. And then just turn right to face it. We're getting some video here with the camera systems on the elevator of the ROV working on the seafloor. These videos are pretty instructive to give people a sense of how we're using this remotely operated vehicle technology to study the seafloor. It also operationally helps the pilots sort of understand how the vehicle is behaving and interacting with the seafloor. That is sometimes quite useful. So you can just stop right there and go up and down a little bit, and maybe forward and back, and maybe spin if you want. But I would come up just a little bit. Yeah, that's good. Come up just a little bit more. Keep coming up. Okay, that's good. And so then I would turn left. And go forward just a bit. Yeah, that would be a good idea. So you're 3 meters up. Yeah, that's good. Yeah. And okay, you're just about over the current meter now. So can you turn right? And just hold that. Just for a few minutes. Where are the lasers? The lasers are on this camera here, right? So hold on. So if I'm pointing this way, okay, can you turn them on? Okay, lasers off. All right, great. Can you now come up and go to the right a little bit more, and we'll go around the right side of the elevator and turn the lights off.
Okay. Do you want Jason maintaining facing the elevator?
No, I think for now you can just come up slightly and then turn to the right, so we get a broadside view, and then basically go to the right of it where the switches are. Pretty good lava terrain though, as a backdrop. That's good, and I would, yeah, that's it. Yeah, turn a little bit more, and up a little bit. Okay, now turn on your starboard lights so you can see what you're doing. There you go. Okay, now turn left and go back to the elevator. I said turn left. No, I didn't say turn them off. Turn left. Sorry. There you go. Okay, and then you can go up to the switches. Can you take a 4K of this? Okay, we're going to turn the lights off on the elevator while we go and do the next operation, which is deploying the current meter and inspecting Bio9 Central and South. And you can just grab those loops and push them to the right, and we'll have plenty of battery power left for the imaging at Tica. Well, I got 40 amp hours on each battery, and they each of the lights draws about 4 to 5 amps. So got a couple hours if I left everything on for all the while without draining the batteries down too much. Yeah. Okay, stop the clip. Did you stop the clip? Thanks. That's good. And if you don't mind, yeah, put the bungee on. Just make sure that it doesn't come on inadvertently or if it gets bumped. Yeah, it is. You have to push it with your, just push it with a manips, with a closed manip. Actually, nothing's turned off yet. Go ahead and push on the ear. There you go. And I have to do it to the other one too. There you go. Let's turn it off. Okay, great. Okay, Mario. What's that? I'm sorry, say again. The bungee on the top switch? Sure. Yes, please. Yeah, I forgot that you didn't do that. Yeah. Thank you. Great. Okay. All right. So if you could just back away from the elevator and turn left. Right. No, I want to go basically just a little bit north of Bio 9, like right about there. So if you could just ride up. Okay. Yeah, that looks fine. Thanks. Thanks, Mario. Great driving. Okay, I'm just trying to get the camera centered up on the vehicle heading so that what we're heading is the view that you're looking at. Right now, we're just basically looking north. He's going to just back up from the elevator and turn to the left and go into the axial trough. Just a short traverse of a few tens of meters. And we're going to find a landing spot to put this other current meter, get a good fix on it, and then we'll go and inspect the Bio 9 vent area. Are we looking for corals now? Is that the plan? Okay, this little drop off that you're seeing is the drop off along the eastern wall of the axial trough. So we're going to drop into it. It's got a relief of about maybe 7 meters or so. So we're going to go about 20 meters and then drop down in it and go to the floor. It's a big jumble of chaotic collapsed lava surface crusts and flows, largely sheet flows and Hackley flows that were erupted in this area in the 2005-2006 period. All right, as soon as you're clear of the wall, Mary, if you could go down. So right now we're hitting just 260 or so, 265. That's great. There you see some good shots of lava pillars. That's the terrain that we have in the axial trough here. These are all created during the eruption as water is trying to escape, and the lava congeals around them and freezes around them, and they form these fantastic looking pillar structures, similar in a certain sense to lava trees in Hawaii, for those of you that may be familiar with that phenomenon when lava comes out and goes over a forest. Here you can see in the distance that tall spire. That's part of the Bio-9 complex, just east of this series of ramparts and lava pillars. So yeah, we'll want to go maybe a little bit due north, a little bit further north as you're going in. Those are the two Bio-9 spires. Tito, did you hear that? We want to go a little north. Is that okay? Yeah, we don't want to go north. Okay, that's fine. Yeah, that's right. Right. Okay, those are the Bio-9 chimneys, the northern one, and then we have instrumented the central one and the southern one. We're going to go north of that, so you want to basically ride to the north here. Yeah, so turn right, please. Okay, you can see in almost the center of the screen one of my loggers there, one of the high T loggers that we deployed. So that's in the central. It's a chimney, very active chimney, central to both the main two spires, the north and the south one. It's in the center of your screen. It looks like a little striped rectangle. Okay, let's keep going north, Mario. We're going to go north a little bit, yeah, a few 5 meters, 10 meters to find a place for this current meter to live. Yeah. Yeah, 5 or 10 meters north. We'll just see what's there, and we'll get down on the bottom. So that's the northern Bio-9 chimney. We're heading sort of 310 right now. So it's going to go down our port side as we traverse here up to the northwest. We're at about 7 meters altitude. That chimney is about 9 meters tall, 10 meters tall. Good. All right. Keep coming down. It's looking pretty good. So let's see what's going on around here, where this crab is, in terms of a spot for the current meter. Yeah, so right there in that spot right there. I'm sorry, say again. Oh, sorry. Let's see. Actually, Mario, I'm thinking. You see this little mound, this little pressure ridge right here. Let's just look at that for a second and see. Maybe might not be a bad idea if we tried to put it up on the top of that. Because if an eruption comes out, at least, and doesn't reach this area, it would survive. So how about up on top of this pillar structure here? Let's just have a closer look at that. Yeah, so this is 10 meters Okay, so stop for a second. Let's just stop going forward. Right, so we've got Bio9 behind us by maybe 20 meters. We're up on, what's that? Yeah, to the northern one. Okay, so I would say right here is not a bad spot because it's not right at the floor where the first eruption's going to get it and eat it. So let's maybe put it in here. I mean, we're definitely down below the rim. So let's turn left and let's have a look at this area in front of us. If there is going to be an eruption and we put it way down at the bottom, that's the first thing that's going to get affected. And we're definitely below the rim level here. So if there's any difference between outside and inside, we'll hopefully be able to get that in the data from the tide gauges or from the current meters. Okay, let's go and try to set up here and see what it's like. A little hard to tell how steep it is there. There's a flatter spot up on the top. Yeah. Okay. Deploy what next to the crab? Yeah, I'm just trying to gauge here. I mean, it's looking pretty good, right in the center, right here, or between these two rocks. Or, I mean, we don't want to have it so that the current meter can't move. But nestled right on top here, I think is good. Yes, it's a tilting current meter. Yeah, that's what TCM stands for, tilting current meter, made by Lowell Instruments in Cape Cod, North Falmouth. So right around there. How does that look? Okay. Can you record this, please? Okay, this is hackily jumbled lava here on a rampart in the axial trough, just maybe 10 meters north of Bio9 vent. This looks good, Miriam. At a depth of 2512 and a half, 2512 meters depth. Yes, please. Then the serial number on the last one was 23, right? This has all the same numbers, but this is 24. Okay. Move it over. Can you move it over to the right, please, a little bit? Okay, let's try that. And no, let's put it maybe let's put it in front of this rock right here. Well, can you reach to here? Okay, so let's try to put it right there. I mean, it is, yeah, hackly lava crust there, but I think it might sit better. Oh yeah, I like that better. That's good. That's fine. Release that. Let me try to get this damn camera to pay attention to me here. What's that? Okay. Charlie, you still recording? Yeah, stop it. Okay, I took a snap of that. Okay, we deployed the current meter. Very good. Okay, let's go take a look at the loggers in Bio9 Central and South. So they're basically just right behind you. What's that? We're going to go there briefly, and then we're going to head back, get the elevator, and go to Tica. And so I'd like you to go around that structure on the west side, Mario. That's the side that we can access and see the central chimney that we instrumented, and then we can go around to the south one. So we'll basically go down the west side first, the west side of that guy, right? Right. So if you head west a little bit and then south once you get to the right of that. Yeah, west until we just clear it, and then can you? Yeah, there's a good picture in my view too of it. And can you position the port manip up a little bit? Sorry about that. Thank you. That's good. I think that's good. Yeah, that's good. Thanks, Mario. Yeah, just one second. So we just want to make sure that, so yeah, these are the two structures here. You see these bright spots in the forward sonar. So you're going to want to be just on this side of it to go like that, right? So it looks like you're lined up pretty well. You may be a little close. You might want to, yeah, there you go. Okay, just coming up to it right here. There you go. So yeah, so you're going to want to go in this area here. Yeah, to the right of the base of the structure. Yeah. Okay, so that's the north side of the northern Bio9 chimney structure. I'd rather you didn't. I'd rather you stay down low because the central one is down low. So if you come up over the top, it's not going to give us the view that we want. So I'd stay down low and go and come over here. What's that? About 10 meters, 11 meters. I mean, the chimney that we want to go look at is the first one is right there, right in here where my logger is. So that's why I want it to be down here looking that way. And then we're going to go around the far one again around the south side. So we're going to sort of circumnavigate these things. No, I get it. I get it. I mean, you can look at my camera too for the view here. So there you can see the logger in the chimney in the Bio9 Central, just coming into view, that sort of little striped rectangle. And I think actually, Mario, that's fine. You can just keep driving that way if it works for the cable. Yeah, just keep driving in. Yeah, just keep driving southeast, right? Okay, there's the Bio9 logger just coming to the left side of your screen. In that short chimney structure that's in between. try to brighten it up a little bit so you can see it better. We've got a yellow polypro marker. That's the central structure right here in between two vigorous smokers coming out of that sort of stumpy vent. And then the southern Bio9 structure, you can again see the logger that's installed there at the base as we're sort of circling around. Great job driving, Mario. This is terrific. This is just the view we wanted. Yeah, so, and you can keep lateraling to the right. And we're at about 7-8 meters altitude, so we're riding a bit up above the structures here. You can see the base of the structures, quite a large sort of apron of sulfide, and depth here is 2507, but down at the bottom of the AST floor, it's about 2515. And the southern chimney structure is quite decorated, has that tall spire. We chose to work down towards the base. The vents are hot, or the orifices are hot, and it was just going to be too complicated to try to work up on the top of these vents. Okay, so let's just keep coming around, and then after you sort of get clear of that southern logger, you can basically head back up to the elevator. Okay, so just go past there and then head back to the elevator. Can you take a 4K clip? Sorry if I'm in your way. We're just doing a watch change now. So the pilot's engineer and navigator are exchanging information about what they did and what's transpired and what the plan is for the next 4 hours that they're on watch. So just be a couple of minutes before we get going. Somebody asked in the chat how the vents get named. In this particular area, we just basically started using letters as we discovered them back in 1991. It's sort of an alphabet soup of vent names going from A to I can't remember what the A to going to L for sure. I can't remember if it's well, no, A, L, M, yeah. I think M may be the furthest down on the alphabet we went. In other areas, people name them after scientists who have focused on studying hydrothermal systems. Sometimes we get creative. There's some in the southern East Pacific Rise named after cartoon characters. Spend a month at sea and you get a little loopy, but it's all basically sort of up to the science party. And we try to be respectful in terms of naming things after individuals who have also made major contributions to hydrothermal vent studies. For instance, there's one named after John Edmund, a professor at Massachusetts Institute of Technology, who was instrumental in the early sort of days back in the mid 70s of understanding hydrothermal venting and being part of the discovery of hydrothermal vents, and Karen von Dam, who was the advisor to Jill McDermott, who's one of the co-PIs of this study. And Karen, since the early 90s, has been a leading driving force, or was a leading driving force in study of hydrothermal vent systems. Unfortunately passed away in 2008. And there are two vents in the Indian Ocean, which when we had a program there in the late 1990s, we named both after John Edmund and Karen von Dam. Yeah. Oh, somebody has also asked about 4K. So it's there's a variety of resolution of the imaging chips in cameras these days, and some of them extremely high resolution, going anywhere from regular high definition, which is sort of 1,000 or 1,080 pixels, up to 4K, which is 4,000 pixels and beyond. There's an amazing amount of technology advancement, which has helped us to do imaging in the deep sea. A variety of companies, including Deep Sea Power and Light, that makes some of the cameras that I've been using, have been instrumental in that. But also the question sort of speaks to just even consumer electronics. The cameras that I have in the camera system on the manipulator that we're using are basically GoPro Hero 4 cameras inside a Deep Sea Power and Light housing. And then we also have still cameras, which are taking digital still pictures, and they are 12 megapixel looking forward and 24 megapixel looking down. All right, I'm gonna have to stop and direct the pilot now that we've done the shift change. Okay, Chris, hi. We now have Chris Judge as the pilot, Ronnie Wims as the engineer, and we've got Nick Ozatia in the navigator seat. Nick is an Alvin pilot in training and has come out to help us on this cruise. So we want to go to the south of that Ballyonoun South structure, and then head up to the stadium area, to the elevator, and get the elevator and bring it to Tica and start working at Tica. That's the next series of tasks. We're not recording 4K now, right? Yes, please. Okay, thanks. It's right at Stadium and Benchmark 3, but you can certainly turn it on. But that's where it is, where we put all the stuff right by it. So I would just head right up there from as long as you get around the south side of this vent, then go ahead and get up there. So we're going to traverse now another 20 meters, 30 meters back up to where we left the elevator. You're going to want to ditch a bunch of plates from the elevator. We couldn't do it when the tide gauge was in there, but now that whole area is free, so I would, pull out as many weights as you want. In fact, it's better to do it out here so that we're not doing it in the actual trough. So this is a small structure here. This is Riftia Mound, which has been the study site for the biologists here on this leg, and it's an active site just adjacent to the Bio9 vent system. Yes. Right. So the Bio9 vent fluids, what was our highest? 364, 370. Yeah. So they're hot and they're getting hotter, Mark. That's part of the data that we've been collecting as a time series over the last 3 years, and using the temperature as well as the fluid chemistry of the vents to understand where the magma beneath the seafloor here is, and whether it's shallowing, meaning whether the magma is inflating in the crust and interacting with seawater. You can tell that based on looking at various chemical compositions of the fluids, and using that as a guide to almost as a barometer of where the reaction zone is between the fluids and the magma. We just did a watch change here. Rose Jones from the University of Minnesota, a postdoc with Randy Toner, is the watch leader. And we've got Bill Dowd from Lehigh, and Natalia Barreyre Rivera from an undergraduate student at UCSD, who is working with Ross Parnell-Turner, who's one of the co-PIs of this this project. we're going over the collapsed lava pillar and rampart terrain here in the eastern margin of the axial trough near Bio-9. We're going to come out of this in just a minute as we come up and over the edge, which will be very shortly. And then we're going to go back to the elevator, ditch some of the steel plates that's on it, and make it a little lighter so it's easier to carry and maneuver. Here you see in the far distance the three sentinels that we've got there. We've got the benchmark in the middle and the tide gauge to the left, and the current meter that was deployed right around benchmark number 3. The elevator is sitting just a little bit to the east of that array of instruments. Okay, I'm back in the van. I just popped out to get a very quick bite to eat. So we're heading up to Tica. The biologists have been working extensively here on this leg. Lauren Molyneux is the lead biologist. Sean Arellano from Western Washington University and Costa Vitriani are her two co-PIs. They have several projects here, and again, a time series of work that they're going to be doing to study a variety of biological processes. If you happen to tune in yesterday to the YouTube link that was hosted by Hui, by Woods Hole Oceanographic, they broadcast a lot of the work that they were doing at that site. So we're working there to basically sample the high temperature fluids. So it's a site that's of great interest. I don't know if Jill McDermott is on. Jill, if you're on, you might want to just briefly chat in general terms about why the sampling at Tica might be important to understanding the hydrothermal system here at the EPR. Jill may be back soon. We've got a number of our co-PIs here. Ross Parnell-Turner from Scripps, who's hosting this particular Zoom, and he is a marine geologist, geophysicist. Jill McDermott, hydrothermal fluid chemist at Lehigh University, and then Thibaut Barreyre at the University of Bergen in Norway, who is a longtime collaborator of mine and a student of Javier Escartin, who is a collaborator of ours, focused on some of the imaging and mapping work that we're doing. And Nuno Garcia at the University of Girona in Spain, also an imaging specialist, who's been working with us on collecting high resolution 3D imaging of the vent structures and then trying to reconstruct them in using structure for motion, structure for motion, fine scale topography, if you will, of the vent structures. So we're just not too far away from the Tica area. We've got maybe 130 meters or so to go. Should get there in a few minutes. They're moving the ship up in that area because we're going to be working there for a few hours. And we have to stay within a certain radius of the ship because of how the fiber optic cable is arranged. And the freedom of movement of the ROV is constrained by where the cable is. It's a very complex system in a certain sense, but also quite simple. And the way that they've arranged the operation is to basically consider where the ROV can operate has to be within the part of the meaty part of a donut, not in the donut hole. And that donut represents the area around the cable, basically, which is what the ROV is attached to. And we've got USBL ultra short baseline beacons, acoustic beacons, both on the cable and on the ROV, so we can tell where the cable is about 100 meters or so up from the ROV. That section of cable between the ROV and the beacon is floated with what look like footballs. They're made out of syntactic foam, so they float the cable up that distance, and then the width of the meaty part of the donut is determined by how much cable you pay out or pull in, and that allows the ROV the freedom of movement over probably a 40 or 50 meter area without having to move the ship too much. And the navigator's looking at all of this on a screen that has these various parameters plotted, and with an underlay of the Sentry AUV bathymetry that we've made here over the last few years. Ross Parnell-Turner and his grad student Jun-Nai Wu have worked tirelessly along with collaborator Greg Curris and the Sentry group to produce just an exceptional map of the terrain here at the East Pacific Rise that has a resolution of about 1 meter, and the side scan resolution is about 20 centimeters. So we can tell a lot about the volcanic terrain and the topography here, and it matches very well with our observations. Jill, are you by any chance on?
Hi, Dan. Yeah, I'm here.
Hey, Jill, how you doing?
Good. How are you?
I'm okay. So we're headed up to Tica, and I had just introduced you a couple of minutes ago, and mentioned that maybe you could chat briefly as we're transiting up. We've got another 5 minutes or 10 minutes to go, about why you thought the Tica fluids might be important in terms of understanding the hydrothermal system in the EPR at the 950 area.
Sure. Just let me know when you'd like me to chat.
Well, why don't you do it now? We got another, maybe 10 minutes of transiting up there, and then we got to get set up. So this is probably a good time, and then we'll have to get into the thick of it in terms of seeing, what your view is of the vent structure that we're going to be sampling, and the temperatures, and which bottles to fire where.
Okay, sounds good. All right, I'll start talking then, but let me know if you want me to stop if you have something important to say.
Sure, no problem.
Okay. All right, well, good afternoon, everyone. Well, afternoon here on the East Coast in the US. This is Jill McDermott. I'm an assistant professor at Lehigh University. I'm a PI on this project as the hydrothermal fluid geochemistry leader within our team. And so before I talk about the vent that we're headed to next, which is called Tica vent, I'll give you just a quick snapshot overview of our overarching goal at 9 North on this project. So as many of you might know or might not know, this is a very active, volcanically active part of the mid-ocean ridge crest. And 9 North last erupted about 15 years ago, and prior to that, 30 years ago. So there are 2 documented volcanic eruptions on record at 9 North, which makes it fairly unique place on the seafloor in that regard. What we're hoping to do in this expedition is to capture the lead up to the next eruption, which is now due to occur essentially at any time here. So we're doing this using a combination of geophysical measurements involving the sensors that Dan's placing on this dive, which include current meters and a tide gauge, and also the in situ temperature loggers that Dan's also been placing. In addition to this, we use hydrothermal vent fluid chemistry in my lab to understand the temperature and pressure of hydrothermal fluid origin across the entire axis in this 9 degrees 50 north latitude on the East Pacific rise. The reason this system is so interesting is that each one of these different vent fluids that you've been observing this week are they form at unique conditions in the subsurface. And by unique, I mean each vent has its own special characteristic temperature and pressure of origin. And the other important facet of 9 North is that those conditions change quite dramatically with time and with space. And so any one location at the EPR, like Tica vent, for example, might be chemically quite different from year to year. And those chemical changes can reflect changes in the origin, temperature, and pressure. It's important to us to understand that origin, temperature, and pressure, because this also gives us a glimpse into the whole system, really, what the magma chamber is doing at depth. And so what we're interested in seeing is whether or not we can combine our geophysical measurements with geochemical measurements to tell a story of how EPR kind of how it erupts, what happens in the lead up, in the years leading up to an eruption, and then also hopefully in the aftermath of the next eruption. And so throughout this cruise, we've sampled, I think it's 7 or 8 now, different discrete hydrothermal fluids at different locations. And today's first target is Tica vent. So we're headed there now with the hydrothermal fluid samplers on board. The reason we're interested in Tica specifically is that Tica serves as a source fluid for all of the biological communities that you were looking at on last night's biology dive. And so essentially those habitable areas of the East Pacific Rise, many of them reflect a mixing zone where this cold oxidized seawater is mixing with the hot, reduced oxygen pore fluid that's venting at Tica. And so we are hoping to get a good sample of the hottest fluid at Tica vent, which will provide the end member, or the kind of the one side of the mixing regime, in contrast with the fluids where you see a lot of life being hosted. So this was really well characterized in last night's dive. If you were viewing then, you'll also see a lot of animal communities, hopefully, on this dive as well. Just 1 second, I'm going to mute and change locations because I'm tuning in from home here and there's some sound in the background. Hold on.
No problem, Jill. Thanks. That's a great summary and in-depth sort of view of the background for why we're doing this work and why the geochemistry is so important to the overall problem that we're trying to study, which is why we thought it was extremely important for it to be a combined study of not only geologists and geophysicists and modelers, but also geochemists, because that's a key part of the system. And Jill is ideally suited. She has a long history of working both at these specific rise and on other hydrothermal vent systems. So she's got a lot of background information, particularly on this vent site or these vent sites here at the EPR.
Thanks, Dan. I'm back here. Would you like me to keep going?
Yep. Yes. Yes, please. We're about, just to update you, we're sort of homing in on Tica. We've got about 50 meters to go, so maybe another 5 minutes or so, and then we'll get back to ops.
All right, that sounds good. I guess I'll talk a little more about Tica and the different projects that we'll be investigating using the Tica fluids and the other fluids we've collected. So our chief goal here, like I mentioned, is called geothermobarometry, which stands for the thermo meaning temperature and barometry referring to pressure. And the geo part of that means that the hydrothermal fluid itself can provide information about temperature and pressure. And so the team lead for this project is Connor Downing. He's a master's student at Lehigh University working with my group. He's out on the ship right now, and he'll be tackling that really important aspect of our research. The second project we're working on is another student of mine, Billy Dowd, who's a PhD candidate at Lehigh University. And Billy's been working on constraining the abundance and hopefully the isotopic nature of intermediate redox sulfur species within the fluids. The reason this is really important at the EPR is because the vent fluids are really rich in hydrogen sulfide. This is that really rotten egg smell that you smell at a marsh or at the beach during low tide. That's actually one of the foundation molecules that supports life in this environment. And so a lot of these organisms have, they host microbial symbionts, or there are microbial primary producers that are actively oxidizing hydrogen sulfide. The interesting thing about that chemistry is that sulfur has a lot of different forms that it can take in the natural environment. And so the two different ends of that spectrum are hydrogen sulfide, which is the rotten egg smell, and then sulfate, which is a molecule that's really abundant in regular seawater. However, in between hydrogen sulfide and sulfate, there are a whole suite of different interesting, very highly reactive sulfur-bearing species that are often, they're quite difficult to measure analytically. And so I think they can be often not seen or are often overlooked. And so one of the aspects that we're interested in at EPR is constraining how those sulfur species form and under what temperatures and in what kind of environments, whether they're forming in environments with a lot of life or whether they're actually also forming in environments that are devoid of life at the really high temperature vents. So Tica will also be really interesting fluid to tackle this question because it's the hot source fluid for all of those fluids that support life. The third project we're working on is headed up by Dr. Keldon Pear, who's a postdoc in my group. She's also on board along with Connor and Billy. And Keldon is interested in a really important broad question, which is, how does temperature affect the preservation of organic compounds? And so Keldon's looking at their suite of samples that we've collected which span pretty high or a broad range of temperatures that we encounter within these hydrothermal systems. She's looking at the organic trace organic compositions within those fluids, and then comparing that with the organic compositions that she finds in associated sulfide deposits and altered basalt deposits that we've been able to collect. And so those three projects combined are our geochemistry targets for this expedition. And I'm really personally very excited to be back at 9 North, albeit back remotely right now, because this is where I got my start as a hydrothermal chemist a little over 15 years ago. I was working with Dr. Karen Von Dam, who was at the time really one of the world's experts in hydrothermal chemistry in general. And Karen really specialized in the 9 North EPR area. And so my very first dive as a young early career scientist was to this very same vent field that we're studying today. And this is the first time I've been back since I worked with Dr. Von Dam during my first graduate work at 9 North. I think I'll keep talking a little bit. But one of the really great things that I've enjoyed a lot about this cruise is because we've been able to use ROV Jason and incorporate this live stream into our work, I've really been able to see all of these hydrothermal vents within this system here at detail I've never really been able to participate in before or appreciate fully. And so it's been like just such a pleasure. I know about Tica vent, but it's really very fulfilling to be able to see all of these sites in person through this live stream and through the work that ROV Jason is doing here on bottom. It's been very, very helpful to understanding kind of the geometry and the entire landscape that we're working in this environment, since it's such a complex place. I see a question in our chat here, which was, what is the vent fluid temperature? Well, it kind of depends which vent fluid. So the Tica vent that we're headed toward right now, the biology group yesterday, they were able to take a temperature measurement at Tica, and based on what they were observing, the temperature of Tica is around 170 degrees Celsius. So that'll be kind of the ballpark temperature range we're looking for at Tica vent. This contrasts quite a lot with the lower temperature fluids that surround the Tica, the hot source fluid at Tica. Those lower temperature fluids kind of span the whole temperature range from cold bottom seawater, which here at EPR is about 2 degrees Celsius, very cold, up through, all the way up through 170. And so a lot of these really lush looking biological communities, many of them are living at temperatures right around something in the range of 10 degrees, 20 degrees, up to 50 degrees, although the temperature limit for life at hydrothermal systems is actually quite high. It's 122 degrees Celsius. So in principle, any fluid up until 122 could be hosting life.
Hey, Jill, so we're here, we're at Tica. We're at the Riftia clump at Tica, and the vent structure is just off to our left, just off to our west. We're heading about northeast right now. Chris is about to land. So if you don't mind, if we could just turn to some of the operational stuff now, if that's okay. But that was a terrific summary. I really appreciate it.
Sure, Dan. I'll stand by here.
Great. Yeah, and I'm glad that that Ross is recording that, because that little summary is like a terrific capsulation of both the importance of the hydrothermal systems and the fluid chemistry, as well as some of the history of what we've been doing here at the EPR. And so thank you again for that. Okay, so Chris, you've got this muscle structure. Are you getting tugged by the cable? Okay. But it's back and back of this big rampart here, right? So you have to come around to the left. Yeah. Yeah, definitely come left to lateral left and then forward. Yeah, there it is, right there. I'm having a hard time judging how irregular the terrain is here in terms of slope up versus slope down, or whether it's flat-ish right here. But if you were to position the elevator in this general neck of the woods, have a pretty good view of that and would shine some light on the structure. Yep. Okay, that's right. So right now we're heading north, but he's using his thrusters to lateral west. So that's looking pretty good. How about here? Can't tell exactly how far in front of it you are, but it's not very far. You have enough room to work in there if we do put the elevator here. Yeah, so that one right there. Yeah, right. We're using the forward-looking scanning sonar to help gauge how far we are away from the various structures. I think this is probably pretty good. It'll give you enough room to move around it, and it'll be close enough so that we'll get probably pretty good view of the ROV working here. So let's set it down, and then we can make some adjustments after we turn on the lights. I know the view in the screen that you're seeing is not very good. That big yellow block is the syntactic foam. Not much we can do about that while we're carrying it around with us. For the rest of the dive, we won't have it with us. We're going to be working with it here at Tica doing fluid sampling. You'll see we'll be switching out some of the titanium major samplers that we're using to collect the hydrothermal fluids that Jill was talking about. And then we have some additional ones on the elevator. We'll switch the bottles out and we'll keep going north for the rest of the dive. And the elevator and those bottles that were just sampled will come back to the surface. And Lehigh chemistry team will be processing those during the rest of the dive. So it looks like it's hitting, which is good. Looks like there's a little bit of a slope here. Yeah. And how about if you move it forward a little bit, like to right here? Because it does look like it drops off there a bit. So deceiving looking at the. And it may be. I mean, I don't know if this is better. Perhaps a little bit further to the west. Let's try. Yeah, it does look a little more benign and flat-ish. And I think we'd still get a reasonable view. So let's put it. That looks pretty good. It's quite deceiving looking at. Yeah, I wouldn't go more left because I think then you have this structure here right in your way. So let's try to just land it there and see how it looks. I just can't tell whether there's a big slope there. I think it's on the ground. Yeah. So let's see what happens when you let go. Okay, we've landed the elevator. Can you see what you can do about improving the image after we get the block out? Yeah. Okay, what is it doing? It's behaving more or less. Yeah, okay, well, we're just, let's go behind it here and just drop down so that we can sort of eyeball it and use my camera as a viewfinder. That's great. Okay, so we're here at the Tica vent area. We're just trying to get the elevator arranged so that we can be able to use the imaging systems on it as we're taking samples and working here around this vent site. It's going to throw a fair amount of light at the structures too, which will be helpful for our imaging goals. And you'll see that once we turn them on. We have some deep sea switches that I designed with the engineers at Woods Hole. It's simply a magnetic reed switch on a slider that when it makes contact, it turns on the current. Here you can see the sheet flows in the axial trough floor where we landed the elevator right by the Tica vent area. And these are all 2005, 2006 flows. So these are lavas that were erupted 15 years ago. Some of those rectangular blocks that you see with a little rust-colored debris around them, those are Alvin dive weights. There have been many dives with Alvin here in this area for a whole range of biologists, chemists, and geologists who are studying this system. Alvin uses these weights to descend and to ascend from the seafloor to save power. So it actually uses the vehicle's buoyancy to come up once you get rid of the weights. You okay? Yeah. So that's looking pretty good as far as a place, but let's turn the lights on. What's that? I'm not sure exactly. I think. Well, I thought it'd be good for you to turn on the lights first, and then square up behind it, and we'll get a view with the manipulator camera, and then and you see that anemone down on the floor there. That anemone is, it's got to be no more than 15 years old because the lava that it's sitting on is that age. So there's a way for both the biologists to use the volcanic sort of terrain and system to study the sort of evolution and growth of the biology, especially that particular animal, because it's sessile, it's attached to the rock. That's how it lives, and it filter feeds. Can you just open up the eyes? So just do the best you can, even with a block there for now. So you see where the lights are to turn them on? You just got to get the green loop on the top and the yellow loop on the bottom and pull the switches forward. Okay, that's a little too much light, sorry. Let's turn that down a little bit. No, the other down. There you go. Keep going. Yeah. We're going to turn the lights on in the elevator, and then we're going to go behind it, use the arm camera, which has a similar field of view to the cameras on the elevator, to see where it's pointing. That'll give us a good sense of where, whether we have to adjust the direction that the elevator is pointing. Who has the dive plan here? Okay, thanks. Where does this go? Here. And the bungee just gets pulled forward and back. It's that top loop that you want to get. The top loop is the release for the bungee, that one. There you go. Okay, that's free. You just leave it alone, and you can just nudge the switch with your arm too. Yeah, just make sure to push it past the detent. And that one is for the top lights. Can you pan up, please, so you can see the top lights? Come on. Okay. Yeah, just okay. That's good. Go down, Rose. Yeah. And that's a good view there. It's the green one that you want to get for the bungee. These are all things which are important in terms of how you use this equipment, making sure which little polypro ring is attached to which thing, because it has operational implications for the pilots in terms of what they're doing. Okay, so now there's the bottom lights just turned on. Okay, that's great. It's got the detent on. Okay, now let's line up just behind it, Chris, and use the arm camera as a bit of a viewfinder to see how we're situated. Looks like we'll be able to get to the base of the structure with the vehicle at the base of the structure, which is looking pretty good when you're working at it.
Based on the basket in the elevator, it's like a pretty square.
Yeah. And can you come down just a little bit so you're at the level? So you put the arm at the level of the frame of the GoPro on the top of the green frame. So yeah, so I think that's going to be pretty good, actually. I think that's good. Let's leave it at that. Okay, so now we're going to go. If you don't mind, can you turn off, well, once you get around it, it'd probably be good for you to turn off the starboard lights and the lights on a stick.
Okay.
Or certainly the lights on a stick, because yeah, that's not good. Can you do that, or does Ronnie have to do it? Okay. That one's off. That one's off. Okay, good. All right, can you run with that? Is it, okay.
So just port lower and port
Yeah.
down.
Yeah, good. Okay. All right, so let's drive over and get to the base of that vent structure for a minute. And if you could come, I know you can't come down a lot because there's that rampart in front of you, but if you could go and sort of face into these tube worms at the base of the structure, that's probably where we're going to want to leave one of Tim's Vemco arrays down in that area. But let's have a look at it. We want to make sure that we're not impacting the biological experiments, so we have to be mindful of those. And here you see the two chimneys here at Tica, and we just got to figure out who's venting what. And Jill, just so you know, the temperature probe on Jason, even though they have both the main and a spare one, neither of them is working. So we're going to need to get either the IGT or something to measure temperature. So there's this little stumpy one, which I kind of like, and it's got hot fluid coming out of it. Could we go and take a look at that one, please, and get some detailed, and maybe if you could set up to the left of it and be sort of orthogonal to the camera. So you spin around to the right kind of thing. So there's the large structure to the right. Sorry, Jill, go ahead. Were you going to say something?
Yeah, I've been chatting with Stefan about hot fluid he'd been measuring for that represents the end member of the crab
4K
spa fluid.
clip.
Is this in the same location? It is?
Yeah, crab spa, I think, is just a little bit to the east. This isn't crab spa here. This is right. This is the high T flow, the high T chimneys at Tica.
Okay.
So this is one, and we're just, everybody please be on the lookout for the biology experiments. So you want to maybe pan down a little bit, Rose, and close down the ISO so it's not quite so bright. That's good. Can you guys still see it there? No, that's too much. Up a little bit, Rose. Next one up. Okay, that's good. Does that look okay on your screen, Jill?
Yeah, that looks good.
Okay, so you can see the flow coming out of the top of that short stubby chimney. What I was going to propose to do is that we sample the top part of it and see what kind of flow we got out of it, and then maybe use the IGT to sample here. But again, it goes to the heart of whether you want IGT here or whether you want to save the IGT for M.
Yeah, I think it's a great idea to sample the chimney first before we take any of the vent fluids
Right.
out, or the
Yep.
samplers out. What I suggest is we use the IGT just as a temperature probe, stow it,
Okay.
and then I'd like to
Yep.
take a Lily sampler here, provided
Okay.
it's,
Oh,
provided it looks good for
right.
sampling.
Okay, so let's do this. Let's we're going to want that chimney sample. We're going to want you to gently take that off and put it.
Right at the point where it
Yes, exactly. Right. Yeah, from the place where it's sort of stubby right there, right? Okay, so port swing arm. Can somebody tell me what do we have in the port swing arm? Anything? I think that there's a marker. I think there's a Q vent marker in the port swing arm, because I put it in there, unless somebody took it out. So we're the watch standards are just looking at their various notes and dive information. I'm just gonna. Are you taking 4K now? Okay, can you stop for a sec? I'm just gonna zoom in and make sure that I'm well in focus here. So bear with me for a second. Whoop, I know that doesn't look very good, but it's gonna look better in a minute. Hold on a second, where? There's, okay, where do you see a marker? Oh, that marker. Yeah, no, I know that one's in there. I thought you meant on the seafloor, sorry. Okay, yeah, so you can dump the chimney sample in there. Okay, so here we've got a pretty good image of the one of the chimney structures here at Tica. And actually, it's just so we're kosher here. Can you pull out the white balance card? Let's do a white balance. Seeing as how it's in that swing arm. So just bear with me again. We're going to try to get set up and do a white balance here so that we have the camera set as best as possible. It's always challenging to take pictures on the bottom of the ocean. We've made great strides to get better lighting, and lighting that basically resembles the spectrum of sunlight. So the colors are true, but a lot of that has to do with taking the time to set the cameras up. So we'll try to do that here as best we can. We've got a target, both a focus target and a white balance target. So we'll do that quickly, and then we'll get on with seeing what the temperature of the fluid is here, sampling the chimneys, and doing the sampling work that we have to do here. Okay, there we go. Okay, Chris is just pulling the target out. He's going to stick it in front of the camera, so you might want to turn your eyes away because it's going to get really white. I've got to basically fill the frame of the camera with white in order to do the white balance. So yeah, just put it right in the center. Whoop, yeah, hold on. Okay, there we go. Let me get, yeah, okay. Yeah, that's fine. Hold on a second. A little bit, if you don't mind. Oops, what do I do? Touch something? Oh, great. What is going on here? No signal. We have to restart the camera for a second here. It seems to have wigged out on us. It says, please check input connection. What's that? That must have gotten pushed. Okay, so just bear with us for a second. We're having to restart the camera. We're not really in the Alps, which is what that is, or underneath a mushroom. Oh, good, thanks. We're seeing some weird stuff on the screen. We have to restart the camera. So hold on a second. What's that? Okay. Yeah, that's fine. Okay. We not have control on the box. Okay, there we go. Got it. You got it. Was I not panned properly, or? That's, yeah. I know. That's fine. Okay. Okay. So miscellaneous once. All right. That's going to be, I guess, good enough. I don't know. All right. Okay. Let's turn the card around. Okay, that's what we got for color. We'll take a quick 4K clip of that. Done. Okay, you can stow the card. All right, now where were we? Okay, so Chris is going to stow that card, and we are going to take a 4K or a chimney sample here. That's a very good view on my camera, is on the manipulator of this small chimney that we're looking at. Jill, how does that look for exposure? Is that okay, or is it too blown out on the chimney?
Looks a little bright on the chimney. Can you turn it down one tick?
Yeah. How about now?
That's better.
Okay, all right, I'll leave it at that. Tim, are you online by any chance? Not sure if he is, but depending on what we do here, we may decide to put one of his low temperature loggers down if we decide to sample this vent here. So we'll see. Those are in the starboard vial box. We've got 5 of these arrays that Tim has put together. Okay, just leave the box open. Let's go get a piece of chimney sample. This material, and Jill can provide some commentary if you want, is really quite fragile. It is basically, you're seeing the chimney here. I'll just try to focus on that for a second. Okay, well, there's a pretty good focus. So you see it's diffusing through several little holes in the top of that structure. The sulfide mineralization there is quite recent, that little black structure there, which is what we're going to try to sample. It's quite friable. The manipulator has a pretty strong grip, and so we have to try to be very gentle. They usually just try to cradle it and then just twist the manipulator a little bit. And if we get lucky, then a piece of it can be held sort of in the curved claws of the manipulator. So that's what's on tap right now. And we've got some worms in the alvanellid worms, small crabs on the vent structures, basically the sort of spectrum of biological community here, including the mussels in the background and the fish in the background. And you can see at the lower right, the Riftia tube worms, all part of these communities here at the East Pacific Rise vent sites. Can you 4K, please? When I am saying that 4K, it's one of the watch standers here is in charge of collecting high resolution clips. We're recording this video continuously in 1080p high definition, but only some of it is being recorded in 4K when we are requesting it. We're collecting quite a bit of it actually, because we have an imaging component to our research that will rely on the high definition imagery, both still and video that we're collecting. All right, Chris is going to work on the manipulator now to see what we can collect for a sample. And in doing so, the objective is to try to open a more direct sort of exit pathway for the fluids, so that we have a more directed flow. That'll be easier for us to sample than get a good fluid sample. The trick to sampling hydrothermal vents is always to try to get the most pristine water that's actually coming out from the crust, and without it mixing very much or at all with the surrounding seawater. So that's really the critical task that we have in terms of both the pilots and the scientists figuring out collaboratively what the best fluids to sample are, and how to get the orifices that they need to be able to put the fluid samplers in them. Yeah, I would even go further down if you can on it. Yeah, down, because it's likely to be more solid at the base, Chris. Yeah, and you're going to need to go into it a little bit more if you can. You can see he's got an incredible amount of fine scale movement of that manipulator that he's controlling with this gripper. Oh, well, there it is. So it's on the side there. And now we have actually accomplished one of our goals, which is to make a better orifice to sample. You think you can move around and grab it? Because it's lying just on the opposite side. So oftentimes when that happens, and in this particular case, because this little chimney structure is quite short and stumpy, a piece will fall down, and we might be able to go down and actually find it and put it in the basket that you see here in the lower left. It's got that RR2102 marker in it. So we're hoping that we might be able to find the chunk and put it in there. Think you'll be able to reach down in there. Yeah. Yeah, I think it basically fell. I saw that it fell down on the opposite side, and I've been looking in my camera here to see which. I think it's this piece here. Look, see that piece right there on my camera right here, just to the base of this tube worm. See that right there? I think that's it. And here you're seeing the elevator right now. That is filming the ROV working. Oh, sorry, pardon me. Yeah, it's right there, I think. Yep, okay. If you want to put it in the forward bio box with the temperature loggers, you can. Doesn't matter to me. If that's easier for you to deal with, right? So you can bring it right over and into something. So that's a pretty good jet coming out of that little chimney structure, Jill. But I don't know how big the orifice is, but it looks like it's got a pretty good stream on it.
Yeah, it looks like a nice focus jet.
Yeah, that's what I mean.
I agree.
It's got two. You can see there. Okay, I don't know if you can see that, Jill, but it looks like it's got a line of small orifices, with the one all the way on the right being the biggest one.
Yeah, I can.
Can you see that? Okay.
Maybe on the left to me. Wait. Or,
Say again.
yeah. The one that's on the left looks bigger to me, but maybe there's something I'm not seeing.
Yeah, well, I think it's that one's the opening's oriented in a little bit of a different spot. But anyway, we'll try to probe them. But I think right now Chris is trying to get set up to see if we can recover that chimney piece that fell down. And it looks like it's right in front of the bottle, because it's that black piece right there, I think. That was what was on top. Right. Right there, right up from, it's right in front of you there, right at the base of that tube worm, that first tube worm. I'm trying to see on your camera. Yeah. Right in the center of the screen, that black thing right there. I mean, it may have broken, but I think that's it. Because I remember how black it was. But that's. Yeah, go ahead. So, let there be light. What's that? Yeah, I think it's that piece there, no? Okay, let's come up for a sec. try to regroup here. Hold on a second. So let me just zoom in for a sec. Okay. So I thought that it's this right here, this thing right here, that black thing. Which one do you think? What do you think it is? See, I thought it was this one. What's that? This? No, this is part of the structure. It's got to be something on top, and that's why I thought it was this black thing right over here. Exactly. Trying to. What's that? Sorry, we're just trying to orient ourselves. Everybody's looking at the screen at the same time, trying to figure out what is what. I think at this point, it's probably going to be better to try to measure the fluid, Jill. What do you think?
Yeah, I agree, Dan. Maybe at the
Okay,
end we can try to look at the piece.
Yeah.
Or
Okay,
do
so
you think
let's
the
go ahead.
diameter is too wide.
I'm sorry, say again.
Do you want to try to break a second piece, or do you think that chimney is too wide?
I think it's too wide. We sort of got it at the place where it was going to be sort of easiest to sample. But we may look around the other side because it may be. Chris is saying he thinks it may have fallen. There's a little bit of a slope away from us, and it may have fallen there.
Okay.
It's 4K. You're recording 4K? Okay. So those look like baby tube worms to me on the side of that structure. No, I'm a geologist, though. What do I know, right? But that's what they look like. Okay, so we're going to use the IGT to measure temperature.
Yeah, who's on watch?
Yes, it's Chris. So it is Ronnie Wims is the engineer, and Chris Judge is the pilot, and Nick Osadskia is the navigator.
Okay, thanks. Do you have a Lehigh member to work the software?
Yes, Bill is going back to the computer. Rose is here, and Natalia is here.
Okay, just make sure Billy knows we're taking a temperature but not sampling.
Yeah, we're taking a temperature, but not sampling, Bill. Okay. And we're using the J2 ICL2. See, I thought for sure it had fallen there, right? Because I don't see it here. What, this thing right here? Maybe. Oh, maybe you're right. It's there. It's still smoking. That's it right there. Okay. All right. Well, we know where it is. It's between that tube worm and that tube worm. Okay. We're using the tube worms as reference points here. Okay. What do you think? It's about a meter high, or? I mean, I know it's built on a base, but no, that's fine. Yeah. No, that's fine. Yeah, I mean, okay, your view is going to be obstructed a little bit, but I'm going to focus mostly on the sampler as it's going into the fluid, so Jill can have a good idea of that. And you can see the top part of it is diffusing quite vigorously. While it's made out of rock, these things are more akin to sponges. They're basically quite permeable as they're forming. I mean, more than a meter or two? Yeah, okay, it's deceiving to me. I'm actually zoomed all the way out here, but okay, well, maybe a meter and a half, 2 meters. All right, we're going to get set up to take the IGT and put it in the manipulator now. What's that? Yeah, it's the only IGT you got. Sorry, I'm just focusing in here.
Dan, does Billy have comms on the IGT?
Hold on a second. Bill, you have comms on the IGT yet? We're waiting till we pull it out.
We can turn it on now and have Billy start recording the temperature file.
Okay, she'd like you to turn it on now and start recording the temperature file. Okay, he's doing that right now.
Thank you.
Is that right? Can you not get, I think that Polypro is not as floaty as it used to be. Right. There you go. Yeah. You still recording 4K? Okay, you can stop now. You can't just grip the bungee with your fingers and pull it off. How about up where it's on the top of the T handle? Just put your finger back in there. There's a little ridge where you can do that, like that. And now pull. There you go. That way. Exactly. Oh, you got to get a little lower down on it. That's it. All right. There we go. A little housekeeping. Can you record 4K? We're taking pictures of the surface of the chimney here at Tica. There you go. That's better. That's it. Got it. There is a small groove in the manipulator grip that's designed specifically for catching the upper part of the T handle of the sampler. And just watch as you're coming up with the bungee and the snorkel. Yeah. Okay. There we go. Stop. 4K. Okay, here you can see the isobaric gas tight, the IGT, coming into view. That has on it a sensor that is going to measure temperature. That small thin hose or tube right by the nozzle of the sampler is a temperature sensor. Say again? ICL1 should not be on, right? Okay. Okay, we're just trying to position the
Are you getting serial data? So like the standard timing. Yes.
you want the headphones so you can talk to Jill? Here.
Hey, Joe.
Hi, Billy.
I'm just going through the trying the restart the software process. I might switch to the other laptop.
All right.
It's given the standard 273 Celsius error.
Okay. But it's pinging water bottle 1.
The battery volts are 0 right now, so I don't believe it is.
All right. And it's.
I already
you
closed
check
the
with
virtual program as well. What was that?
Okay. Did you check that there's just one ICL powered on and it's the right one?
Yep. Yeah, just ICL2 is on right now.
Okay.
Yeah, I'm gonna try switching computers. Say hi to Matthias for me. Yeah.
How's it going, Billy?
Good. Just starting up the VMware on the second computer.
All right.
Yeah, so the first computer was first reading the -J error. Then I turned off the program and it read that error again. And then I started the virtual machine over, then started reading the 273 Celsius.
Were you seeing hashtag WB1 over on the left side?
I'm not quite sure. I'm plugging in the ICL right now to that second computer.
Okay, we'll see what this one does.
Not yet. I'll let you know though. I got the software open now. You checking something? So port 1, water bottle 1. So yeah, I got the hashtag WB1 on the right side. Water
All right.
bottle 1, port 1, scan. And I'm getting the -1. Oh, magic touch. There you go. Yep. Is the it's in. Okay. It read for a second. I just need to get the connector in. All right. Now we're getting temps. Here, wait. It's intermittent right now. Just there's a 260 Celsius as well as a 320, but it's up. There we go. Yeah, 221. Could you zoom in? Yeah, thank you. All right. All right, we're getting a 266 reading. Nothing right now. Little bit. Now it is 273. So the connection was a little flaky, but now it's reading the one error that we see a lot. So let me sleep this. Here, let me, where's the ICL one? Oh, you just screwed it. Oh no, keep it screwed in then. Get a better connection. One, good. Not right now. Jill, the battery at 11.7 volts is okay, correct?
Yeah, that's a fine
Should
battery.
be between.
Really.
Got it.
Yeah, that's okay.
Okay. So now I'm getting the -1 J error again. Close this here. Let me just disconnect everything. Go, just get the other one in. Yeah. You could just leave it loosely for now. Sometimes when it gets screwed in it, you can't mess around too much with it. Okay. Yeah, we're getting it. All right. Good. Terminal port 1. Come on. Oh, there we go. Yeah, it's a connector problem.
Did you get a reading, Billy?
I'm just not going to move right now. Yeah, I'm getting readings.
Can you read them out?
So 214, 212, 209, 210. I don't want to move my hands because I got the perfect connection. 194, 194. 191. Got it. 190. Error. Come on. Okay. I got an error right now. I'm trying to get a good connection.
Billy, is it a problem, the USB port connection?
I believe it's the one between the Jason ICL cable and our cable that plugs into the USB.
Okay. So this is something, something in the van, not one of our cables.
I don't believe so, no. One of the other watch standards is going to get Kelvin Connor as well. Because they might have some little tips they've been dealing with.
Right. Well, okay. Well, we shouldn't spend too long here because I'm nervous that the IGT might get too warm.
Okay.
Did
Oh,
you,
got a
were you
signal.
satisfied with a max reading?
Hey, I just got one right now.
Oh,
just went out,
working now?
but it was around 180. Yeah, I got a max was 279, but I'm not confident that that was a true temperature or not.
Okay. So can you ask them to stow the IGT and put it to idle?
Okay, you want to stop taking temperature?
Yeah, I'd like to
For
take
now.
yeah, next sample, let's take the Lily sampler. I think it's a good temperature. Yeah.
Okay, that's fine. Joel's asking to store the IGT and take a Lily sample at this vent. Oh, here's Dan.
Hi, Jill. You hear me okay?
Hi, Dan. Yeah.
Hi. Yeah. So I'm just asking Chris to do a little house cleaning here at the vent because we have a piece of it in front that's really preventing us from getting a good idea and from, I think, doing the best job we can of sampling it. And so he's going to try to get rid of a little nub that's in our way in terms of the field of view of the nozzle as it's going into the jets, because it's quite vigorous coming out the top. So he's just going to try to get that. Oh, there you go. Okay. Well, you know what? You now have a piece of it. Great. Now, now what do we do? How about putting it on? Yeah, that's okay. That's fine. All right. So let's let it clear for a second. Let's go back up to the vent structure because this whole side, this whole front side of it, I would open up the as long as you have the manipulator clear, open up the bio box in front on the basket, so we have a place to put stuff. I mean that temperature, Jill, that Bill was getting intermittently was pretty, I think, consistent with what the biologists have been finding when they've come here. So, you know, around 260 or 270, I think is pretty reasonable.
Yeah, I actually think that was a real temperature given how robust the flow looks.
Yeah,
and it's slightly gray.
Bill just said Bill just said it was a max of 279. Yeah, max of 279.
That's actually
Yeah.
quite hot for Tica.
Right. Okay, so just give me a minute here because I think what Chris did at the top is going to be useful. Because there's a chunk of the chimney now that he can grab easily that you're seeing just to the left side of the manipulator. That top part, he ought to be able to stick his fingers in just like that and cradle it hopefully and get it in to the front bio box. If the front bio box will cooperate. Okay, so Chris, it's this piece right here, right? And you ought to be able to just go in like that gently, and hopefully it won't break up on you too much if you just be gentle with it. Yes, it is always. Cradle it like your new baby. There you go. A lot more resilient than hydrothermal vents. Actually, that's true. We dropped our oldest son off the table and and down the stairs, and no, they are pretty resilient. You're absolutely right. Poor Sasha. Oh my gosh. Well, not because we meant to, for sure, but yeah, try to get into it a little bit more and then just cradle it because I think it's broken, but it's just sort of resting there at the moment. Yeah, that piece that you've got right there would be fabulous. Right there. That is perfect. It's beautiful. Okay, so again, this is Tica. Yeah, that fluid is sort of clear to grayish.
Yeah, looks like a 270 fluid.
Yeah. And he's going to put it in that forward bio box with the 3 temperature loggers. That looks good. Watch the thumb. Yep, that's perfect. Yep, okay, it's there. It has found a new home with the temperature loggers. They can keep each other company. You can close that. No, forget about the other piece. Actually leave that open because if this works, we're going to put a temperature logger in here. So just leave it open. Okay, so we're going back up and we're going to now use the port arm to put the IGT back in and just measure temperature again. We have, so what's the deal in terms of measuring the temperature again? Jill, do you want to do it again or are we just going to take it?
Yeah, if you don't mind,
Right,
we can
okay.
try again. Is there someone else in the
Well,
van to help Billy?
Well, there's Sam and Bill right now. You don't want to try getting the IGT going again?
Okay, yeah, we can try.
Did they bring up a new dongle?
It sounded like there was a wiring problem, like a cable that could be swapped out.
Yeah, I would like to swap the dongle out for sure. Is Keldon or Connor not around? They're both sleeping. I know. Okay, Jill, this is your call. If you're okay with us taking the temperature here now, are you going to want to take majors? Because we could try taking the major first.
Yeah, we
You
want
want
to take
not-
majors, 2 major pairs and the Lily
Right.
gas tight.
Okay. All right. So let's go ahead. Chris, sorry, a lot going on. So let's take the forward bottles and see if we can take a major sampler and get the temperature that way too. All right, so we're gonna get set up for a major sample. Rose and Natalia. So probably best to stow the IGT. Let's do that first. We are going to take a major sampler. We'll use the ICL on the major for temperature, okay? But I think we need to have a dongle up here just to be able to swap out if we need to. Yeah, I gotta say, I'm not a big fan of these IGTs and how the cable is being managed. The whole yeah, exactly my point. When can we go to optimal to optical? Yeah, I know, right? Yeah. Oh, it's yeah, right. There we go. I think you got it. Yep. Okay. That's good. All right. Let's pick up the major, forward major. I think it's in good enough. It's not going anywhere. It's good. What's going on? Okay. Okay. All right. That's it. Done. Finished. Okay. Let's pick up a major sampler. Do you still have the starboard light on? Okay. In terms of pulling it out. Okay, we're getting set up to take a major titanium sampler here. Okay. All right. Look at that, first grab. Very nice. Okay, yeah. So Chris, look in my camera here. You see where the flow is coming from? You got a really good view of it right there. Yeah, right. So you see there's this, right, this spot, right? You know, where it's exactly. Okay. There, and I think also in back there, there's another two orifices. So let's just see what we get for temperatures there. So the coil that you see in that puck on the manipulator, that's an inductively coupled loop. It matches the coil on the bottle, and we're now going to rotate the bottle so it's underneath those bolts that you see on top of the bottle. Those are the plungers that actually actuate the sampling, and that looks like it's perfect. Do we have connection? Pull up the ICL program, please. I mean, that was, you can't get much closer and perfect than that. So we have a connection. Okay, great, thank you. So this is the way in which we're measuring temperature in real time without having to have all the wuzzle of cables. We're using that coil loop on the bottle and a coil loop on the arm, and the proximity of those two loops allows you to inductively couple the signal, and then we're sending a very low baud rate signal, which is just basically measuring voltage, and we're converting it to temperature. And that's how we're able to get a sense of where the hottest fluid is on these orifices at the hydrothermal vents. Okay, let me zoom up. And we have a readout here. So now I'm focusing on the fluids that are coming out of the vent structure. We broke it apart a little bit so you can see. Like right there, yeah, and right, and it may in fact break the chimney up. Are you in wrist lock so you can't rotate any? What's the temperature we got? We got 44, 43. Yeah, but you can try to go. I mean, I don't care if that piece falls off to the right. It's the flow is still going to continue.
Can we nudge that piece and knock it off?
Well, he may end up doing that, Jill. He's just trying to get oriented best he can. Now that we have a good connection with the ICL, he's trying to get it so that the nozzles are going to go into that jet that you see. Okay. All right. So now we're going to try to move in. Okay. Hold that. No, 42. 122. That's a nice jump. 122. 158. 175. 192. I like those jumps. 206. It's taking a measurement every 4 or 5 seconds. No, 190, 192. 195. Yeah, so looks like we're not totally in it. 223, 231, 237. Yeah, the difference between being in the flow and out of the flow is millimeters thick, is what Chris is pointing out. He's not moving the arm. And in some cases, especially on a chimney like this, the flow itself, if it disaggregates or dislodges some of the pebbles or rocks up there, it can redirect the flow a bit. So 189, 194, 196. What do you think? You want to nudge it a little bit to the right? 202, 206. You want me to zoom out too? Up above? Yeah, well, we can try for that. It's not, you guys got a better field of view from the from the pilot cam than I do. Yeah, that's okay. I actually think that piece is helping us in terms of directing some of the flow off to the left, right, where you can get at it. But so they're, Jill, they're just repositioning now and going for some perhaps better flow that's over the top. It's probably going to be obscured by this piece in front of us because he's going to drop in over it. He's looking more down on it from the bow camera. Okay, we got, let's see here. There's 66, 85, 94, 147, 189, 210. And how about venting? We're not seeing any venting, no. 220, 223, 225. I'm not sure why the bottles aren't venting. I mean, there's a tiny wispy bit of stuff coming out. 226. Maybe can you come up just a tad? You think you're 227? Yeah, right. Just very, very gently come up. Stop. Okay, well, there we go. That's all right. Okay, now we can see what we're doing. Yeah, now go in there. Yeah, yeah, go towards the back. 72. Yeah. I mean, we got a good strong flow there. 90. 106. $179. 222. 235. 252. Okay, so we're in there. I'm not sure why the left one isn't venting. The right one you say is? Okay, we got 272, Jill.
That's good.
It's venting a bit more now.
Are both bottles venting?
Well, the left one is venting a little bit and the right one is venting a little more. Not sure
Okay.
why.
All right. Is it still stable?
No, this is the view they're getting. Hold on one second. The temperature is stable at 270, 273, 272. Yeah.
Great. Yeah, let's take the sample.
Oh, okay. Okay, we're ready to take the sample. 276 right now. 278. There, the spring's coming up. You can see that on the, no, it's not, spring's not coming up. super slowly. Are they?
Just this forward one.
I don't think so.
This one's moving, this one's not.
You want to stop and go back down?
That's your call.
Jill, should we stop and go back down for another plunge? The right bottle is not
Yeah, I think we should plunge those again. What's the temperature?
but yeah, come out. It's 238 right now. 234. Retract and then extend again. The left one is definitely coming up. The right one is not.
All right, let's just hold it steady.
Can you, do you think you can go back in a little bit? Because we're down at 192. Temperatures dropped. We're at 131, 158, 154. I mean, he's definitely in the orifice, and it's a pretty big one in terms of being able to fit the nozzles in there.
Yeah, Dan, I think the left bottle should be a good sample. Hopefully, it did.
Yeah,
fill a little
we'll yeah. Why don't we come up, try to reposition, and we'll go and plunge again and see if we can't get the right one to trigger. I'm not sure. Okay.
Yeah. Okay.
Still moving slowly.
Well, the left one? No, I think it's to stop. Yeah. Okay. All right. So we're just going to try to reposition the nozzle a bit. Maybe it could be. Yeah. No, it doesn't look like. I mean, there's a little bit of stuff coming out. Yeah. Okay, let's just put it back in. Try to come back up to temperature. It is a line, but I mean, it's not on the plate for sure. But are you all the way in or out, Ronnie? You're out? You're all the way in? It's not even close to the bolt. Oh, it's retracted. Okay, sorry. Okay. All right. Well, the only thing I can think of is let's go ahead and go back in, see if we can get up to temperature, and we'll try to press it again.
Dan, were you able to see if it's lined up with the bolt?
It definitely is. It definitely is. And it doesn't look like it's too far down, but I mean, we've got another bottle to take, so hopefully we'll get another shot at it here. Well, 50, 60, 66, 75, 77. No, I think it's sort of back that way a little bit, and then back towards the back wall. Oop. Yep. 108. No, 98. Maybe go right a little bit. 119. 116. No, 97. 87. 75. 73. Nope. 130. Wait, where was that? Where were you? Okay, go down then to 130, 105, 83. Ah, rats. You take a 4K clip of this? '94. What's that? We're not getting 106 right now. I could have sworn that's where you were last time. Yeah, right, right. You think so? I think it's in back of it right here. I think it's right here. '51, 42. Yeah, no. '75. No, to the right a little bit. 122. Wait. 122. 140. With 200. Okay, that's okay. Now we're talking. Now it's blasting out. Yeah. Okay. So 245. Now the question is 264. Okay. I'm ready. 276. Yeah. Yeah. Go for it. 279. No. Yeah. No, it's not coming up. Okay. Let's stow this bottle. We're done. Let's go get the other bottle and get set up. No, did not fire. So the right bottle did not fire. And I don't think it's going to. Yeah. Okay. All right. Well, we'll just deal with it. But we did remember that spot. So Jill, we'll take the other major and then we'll do the gasite, the Lily gasite.
Yeah, that sounds perfect, Dan. Thank you.
Okay. Thanks. Okay, we're going to get set up to take the other major pair here at this vent site at Tica. Tim, are you online? Is Tim Shank here or not? Okay. Javier, are you online?
Yes, I am done.
Hey, hi, Javier. So,
Hi.
yeah, I suspect that we're going to be working here for about another half an hour or so, and then we're going to be proceeding up to QVent and doing some sampling there. My target for the imaging was going to be MVent, so it's going to be after that. I would say we're probably 2 or 3 hours away from that. I'll have a better estimate here in a little bit in terms of when you want to try to get Nuno and Clement to come in. Okay.
Roger. They are connected. I will be here, so I don't know if they will be available.
Okay.
At the time.
Yeah. Okay. All right. That's fine. I mean, I feel like I have a pretty good idea of what to do, but certainly their input while we're doing it in real time is great. So if they are available, that'd be perfect.
Sure.
Okay.
Hi, Ben. This is Nuno. I'll try to be available. It will be pretty late over here, but one of us will coordinate. One of us will be available.
Okay. All right. Thanks, Nuno. Appreciate it.
No problem.
Are you able to grab the loop or not? The loop on the bungee for the bottle is right here. No. Oh, that's just a zip tie. All right. How about, can you grab it in number 3? You can't get it over the other edge. Man, oh man, that sucks. So where is the loop? Oh, there is a black one right there. It was over on the side. Yeah, not good to have black loops, or at least all black loops. Very hard to see, especially in the shadows. Great job, Chris. Thanks. Yeah, well, no, just whatever. Just if you have to go to it, and it's too bad. That's the one. Well, that's the one we're not using. Thank you very much. So, okay, good. All right. Okay, we're going to get this bottle. We're going to get set up, take another sample. Bill was saying, Jill, that the temperature max we think was about 279. He did see a reading up at 286. Not sure if that was real or not, but it's definitely in that high 270s range.
Yeah, that's great. It's very hot for Tica.
Yeah. Well, it matches to some extent what we've been seeing at the other vents too, which is that they have been heating up since we've been looking in detail over the last 2 or 3 years at these vents, and some of the modeling that Thibaut has been doing with looking at the vent temperatures. I think you need to go like that a little bit to get lined up. Yeah, there you go. No, I mean to get into the slot. I think that's what was preventing you getting into the slot. There you go. Now you got it. Yeah, okay. Next. All right, here we go. Okay, that's the chimney we're sampling right here. Chris is gonna get set up to try to find that sweet spot up at the top of the orifice. You still got room, I think. Yep, yeah. That's pretty good. So what we just did is yeah, I think that's good. That's definitely scraping over the top of the coil. Yeah, we got numbers. Okay, all right. So what just happened is in the field of view of the pilot's camera, you can't see it, but they were just making sure that when the bottle swiveled into that coil assembly for the ICLs, that it was going to clear the puck and clear the bolts, so that it wouldn't prematurely trigger it, but that we would be close enough to get a good connection through this wireless connection through the inductively coupled loop on the bottles. Okay, we're getting set up to go into the orifice now. So that's what Chris is trying to find is the right temperature. We're at, what are we at? I don't know what we're at. We're at 19 right here. 31. 60, yeah, we're at 60. 159, that's a good jump. 207, that's a good one. 227. Yeah, sorry, go ahead. Yeah. Can you see the right one? Going that way, yeah, no, there looks like the bottle. We're 255, Jill.
Okay, Dan, that's probably close enough.
264.
Oh, there we go.
264. 264. And the bottles are venting.
All right. If we're stable there, let's take the sample. That would be a great
257. Okay. All right. I think we're ready to take a sample here. Yep. And Chris, if you can be ready to try to put it back in the flow if it moves. Looked like it did move. 216. $172. 172. Yeah, both springs are coming up. 249. Okay, we're back in the flow, Jill. So we're good after. So hopefully we got some amount of the good fluid. 258. Springs are still coming up. 264. Springs are still coming up a little bit. 272. Springs are still coming up a little bit. 265. 272. Yeah. Okay. I think that's about it. The springs are all out. I think that was a good one. That blue
Yeah.
bottle I think was a good sample. Okay.
That was a good sample.
All right, let's stow that. Yeah,
Thanks,
let's
pilot.
stow that. Excellent, Chris. Jill sends her regards and thanks. Happy birthday.
Thank
It's your
you.
birthday? Whose?
Whose birthday is it?
Oh, it's Jill's birthday? Is it your birthday? Jill?
It is my birthday. Yeah. Yeah.
It's your birthday. Oh, all right.
Thanks for the
happy
vent fluid.
happy birthday. A happy
Thank
birthday
you.
vent fluid sample. There you go.
Thanks. Very nice
Doesn't take much to please a vent chemist. Did you take any 4K of that? Good. Tim Shank, if you're on, can you let me know? What are all those flashy lights? Are they okay? Those flashy lights. Is that normal? Okay, good. All right. I hadn't noticed it. Yeah, right. Okay. Tim Shank, are you on? All right. Yeah. Can someone send Tim a message in the chat asking him if he could get on, because I'm planning on deploying some of his or one of his low temperature loggers here at the base of the chimney. I'll give you a little bit of a view of the basket chaos that we have that Chris is navigating, all the various bungees holding the bottles in so they don't escape and stay secure so they don't fall out. The Lily sampler also has an ICL on it, and hopefully we'll get a temperature on it, although the alignment of that bottle, I haven't done quite as good a job on that, but that was certainly the intent. Looks like we got some space there. Yeah. So we're just bumping out that, you see that ram that's moving on the left side of the screen. That's what we're trying to align. We're trying to get as close to the other ICL on the bottle. You want me to open it up a little more so you can see better? I mean, that's pretty damn close. I know. The plunger's not totally aligned, but let's see if we can get, do we have any comms there or not? All right, let's just go up to the then. I mean, you've got a pretty good idea of where the good fluids are. Oh. Yeah, right, exactly. Okay, this is now a different type of gas tight sampler provided by Marv Lilly at the University of Washington, who's been kind enough to loan it to us. These samplers are smaller volume than the IGTs that are Jill's and the ones developed by Jeff Seawald at Hui. But they are pretty effective as well. It just gave us a little bit more chance to collect additional fluids with the gases that are maintained because the sampler is designed, the seals are designed to be able to retain the gases in the fluid. Okay, so. Yeah. I mean, I think as long as you're in it, just look for a second. No indication of flow, and it basically you put the plunger in and you take the plunger out. So I think Jill, I mean that looks to me to be.
It looks like the same spot.
Yeah, no, I think it is the same spot. So I think we're good to go on this one.
All right. Let's go for
yeah,
it.
I think we're good. Yeah. Right. So, yeah, plunge in all the way and then out. Yeah, there you go. Okay, that's got it. That sample's done. Okay. All righty. So here we go. So here's my suggestion. We need to go back to the elevator and actually, hold on a second. Jill, I guess my thought is we're going to try to put a temperature logger in here. So we should probably stow the stow the Lilly sampler and put a temperature logger in here. We'll see how that works. I'm not sure. Hopefully the structure is strong enough when we push it in that it's not going to disaggregate the top part of it. But I think we should try to do that.
Yeah, that sounds good, Dan.
Okay. All right. So let's stow the Lilly sampler for now, and then get one of the high T loggers out of the starboard bio box. You want this thing back, or should I just leave it here? I mean, I think I've got the exposure setting pretty good when we're on the chimney close up. I think you just had it cant a little bit. Yeah. Great. Okay. Thanks, Chris. And that yellow loop is the loop to put over it. Now it's in. Yeah, exactly. There it goes. Okay. Right, up and then all the way over. Yeah. Okay, okay, that's enough. All right, good. All right, open the bio box, get out a logger, see if we can stick one in the vent. Can you come out? No, yeah, it doesn't matter which logger you pick. Pilot's choice. And again, you might grab it up towards the bend. That's going to be the best way for you to actually put the pressure that you need to be able to insert it in the vent. There you go. That's a good one. Yeah, just slide up towards it. That's good. Perfect. Excellent. Okay, you got it. Okay, here's we'll get a reading of the logger as he's bringing it in. Can you record some 4K, please? Okay, it's 2020-003. Logger number 2020-003 is what's going to be inserted in the Tica vent orifice that we have been working at here. And I think you're going to need to rotate it a little bit down and then in.
So my wrist.
You can't get there from here? And I think it's going to have to come. You have to flip the tip this way, right? I think the tip seems like it's going away that way.
I just can't bring the wrist down.
Yeah, that's okay. I think in this case, it doesn't really matter because there's nothing around it. So I think you could put it in like that as long as it's more, right? I mean, in other words, you don't want to send it out the side once you stick it in. Hold on a second, stop. Let me have this, please. Okay, Chris. Yeah. You're still taking 4K, right? You don't think you're going to push it out too much that way? Are you able to go in? Yeah. Okay. Try to take another. Yeah. 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 I think that was the entire structure that you were. How far down in do you think you can get? Oh, let's give it another try. Well, I would try to see, just gently poke in different places, because it could be that there is an area around the main orifice that's going to be more easily threaded with the probe tip. Keep going in. Keep going in. Can't go anymore. There you go. Keep going. Going a little bit more. No. Okay. No, it stopped. So it looks like the top of the structure is moving, and if you let go, you think it's just going to flop out. Yeah. Okay. Open up a little bit more. What do you think? Nope. Grab it. It's going to fall out. No. All right. Okay. I'm okay with that. We'll leave it. And we'll hope that the chimney starts growing around it. You can stop the 4K. Yeah. Yeah, I mean, it's in it. I don't know what else to do. I think we leave it and we hope for the best here. Okay, the biologists are going to be coming back here, and so hopefully they'll have a look at it. If it falls out, then they'll get it back, but we'll see what it does. I mean, the good thing about hydrothermal chimneys is they tend to make hydrothermal minerals and cement around things, so that's the plan. Okay, so we deployed that 2020-003. Okay, we've got it. Okay, now before you move, I'd like you to look down at the base and see where there's some shimmering water, like in there by the base of those tube worms there. Let's take out from the starboard bio box. We've got one of Tim's temperature logs, low temperature loggers. So you could close that bio box now if you want, the one in the front. The starboard swing arm, sorry, yeah. Yes. And I don't remember if Rachel Heyman is on the line. She's got a much better memory than I do, and Rachel has been one of the leaders in the vent research here at the EPR. She and I started doing this back in 1989, So Rachel, if you remember how Tica got named, go for it. I don't know, Jill, if you know, but I don't remember, honestly.
Actually, Tica was named after I was no longer included in the cruises, so I am not sure. Tim Shan could probably know.
Maybe. I mean, it's always been a biological site more than a sort of chimney site, although it did develop, chimneys and was actually part of the resurgence of activity after the first eruption back in sort of 1996. But I honestly don't remember why it's called Tica. What's the next question? The manipulator arm does use hydraulic fluid. And in terms of whether it's ever been affected by the hydrothermal vents, well, yes, there have been times when it's had close encounters with the vent systems because the pilots are trying to get us the best samples they can, and sometimes some of those are challenging. But remember, even though the vent temperatures are hot, 100 or 200 or even over 350 degrees centigrade, the transition between being super hot fluids like that and very cold, or around 2 or 4 degrees or 7 degrees centigrade, is on the order of millimeters, because you have the bottom of the ocean here is pretty much isothermal, and around here it's about 2 degrees centigrade. So you've got a big mass of water, and even though it's super hot, concentrated right around the chimneys, once they get into the water and are outside the chimney structure, the heat dissipates extremely rapidly, and the transition between that, being super hot and being not hot at all, is on the order of millimeters. Right. Oh, okay. So Chris is saying that in some cases the lenses on the cameras have been affected by the vents, and they've cracked the lenses because of the heat when they get really close. But they try not to. That's why the pilots are so good, is they keep track of all of that stuff while the scientists are trying to ask them to do impossible things. Okay, so now we have our swing arm cleverly sort of arranged so that there's a box of samplers that are in the starboard side of the vehicle that sort of are tucked away, and they can bring that swing arm out. I'll see if I can take a picture of it here. I don't know if I can get all the way to it in my camera. You can just see the edge of it there on the right side, and inside there is that wuzzle of loops. Just pull one of them out. Just pull one of them out, please. And oh, come on, it's easy. Around the red tape. The red tape is up at the top of one of the loops. Yeah. Yeah, grab one of the red ones. That's the label on one of the loggers. We'll take a look at it and see which one it is, and then we'll be able to ID it. I think they're labeled 4, 5, 6, 7, and maybe 8. I can't remember, but any one of those will do. Yeah. Okay. Yeah. Okay, there is an array of, that's number 8. Okay, that number 8 is going to be placed in the diffuse flow underneath the chimney that we've sampled here at Tica. Okay, you can. I think you place it as best as possible, just in that area where we're seeing the diffuse flow in just to the left of where you have it hanging, but up in the nestled in the tube berms at the base of the chimney structure. Something like that. Yeah. Maybe if you can see, it's hard for me to tell where, so just hang on a second. Hold on a sec. Okay, so, I mean, it looks like there's a fair amount of diffuse flow there. I think that that's good. It's right up against the structure. I mean, there's definitely flow coming out of that. You can see it going over the. You're taking 4K of this? Okay, and that is number 8. Okay, that's good. Okay, right now we are heading is 67. So we're heading sort of east-northeast. That means we're looking at the west side of this structure, the sort of west-southwest side of the structure. And that's the side that the Tim Shank's Vemco low temperature Vemco array was placed on. It's right underneath the temperature logger and below a couple of tube worms. Okay, if you can move your manipulator out of the way, and let's take a picture of that. We're getting 4K, Natalia. Okay. I just took a couple of stills. So that's it for the experiment site here at Tica. What do we have on our list? Is there anything else that we have missed doing here?
Do you think we got some albanelids for Sam on the sulfide grab?
I do believe that we got some, yes. And the last time I talked to Sam, he was wormed out.
Okay.
But yes, I believe that there were, because they're all over the surface of that chimney. So, okay. So, right. So we're closing the bio box now. We will then drive back over to the elevator. We're going to do a bottle swap. And then from there, our next stop is up at Q-Vent, where we also have to do a detailed water sampling. Okay, so we got it. Number 8 is here, right? The low T array number 8. Okay. And what lights do you have on right now? Ports? And the butt light. Okay, that's good. Where's Q? Okay, so Q is just up north of Zeta Garden, and it's so it's right here, about 4,478.80, someplace right in that neck of the woods. Okay, yeah. So it's gonna, and now we're gonna release this elevator too. So we're gonna, and before we do that, seeing as how we still have some lights from the elevator, so let's do a couple of pirouettes and posing and whatnot. No, do not. Done. No. We have a good chimney sample in the bio box. That's all we need. Okay, so I would rise up slowly. You can turn and face the elevator lights, which is off to your right, I think. Yep, that's good. And I guess I'd like you to slowly rise up just like you are, so that your lights are not facing the elevator, just come up a little bit. What's that? We don't have a marker for this site, but it's Tica, and there's plenty of biological markers around here. So I think we're, yeah. Just going to try to square up on the, no, let's see, I guess I'd like to know, so you're pointed that way, the elevator is over that way to our right side, right? Yeah, okay, so that looks pretty good. How about now if you, what lights can you turn off? Or you only have your ports to turn off? Okay, so let's leave it at that for a minute. Can you face the elevator now? What's that? Yeah, a 12 megapixel still and the 4K video. No. Okay. Okay, can you record this in 4K, please? Okay, let's come up just a little bit. Great curtain folded lava in the foreground right here. We will eventually, but can you just turn left now a little bit and face the, come up a little bit more. Turn on your port lights. Yeah. I don't know about the elevator yet. That's good. Stop. Stop. No, no, not now. Sorry. And can you go over and just right by the chimney? So there's another chimney structure here. Looks like just east of the one that we sampled. Does not look, it must be diffusing because it's got a bunch of biology and bacterial mats on it. Don't go up any higher. Looks like it's venting a little bit from the top, but it's, yeah, it's definitely got a lot of shimmering going on at the top. Could be similar in terms of the fluids coming out of here as well. It's definitely venting pretty vigorously. Jill, I don't know if you can see that well.
Yeah, it looks pretty similar to the chimney we were just at. Yeah, zooming helps. Yeah.
Yeah.
It's quite similar.
Yeah. So there's two of them. It looks like they're aligned east-west and maybe, I don't know, what, 5 meters apart? 7 meters apart, something like that. And how tall do you think that one is? That one looks like it's at least 3 or 4 meters, right? Okay. All right. So let's back up from it and go back down a little bit. You can leave your light on while we're doing that. Can you turn a little bit to the left as you're coming down to port? Turn to port, just swivel to port. Not too much further down. That's probably good. And now I think you can go ahead and fly to the right side of that and then go and fly up and over the elevator, but you probably want to turn your lights off if you can. You can just fly up and over like that. No, I know, but I'm saying in this orientation with you sort of with your starboard side facing it. And I would try to stay at this level if you can until you actually have to go up and over. Actually, you think you're above the elevator right now? Okay, then can you just come down and stop right here? Sorry, I know there's not much to see at the moment. Just bear with me for a second. Yeah, exactly. So we're doing this to get some images of the vehicle operating on the bottom, which is often a very interesting perspective for everybody to have. It's one thing to be looking at the features. It's another thing to be looking at the ROV that's actually doing all of the sampling and whatnot. So keep coming down. Okay, now can you swivel right and go in front of it into the. Gonna be a little blinded by the lights here, so pardon the movie set, but I think this is good. I think you're centered up really well on this. So keep spinning around to the right. That's great. Sure. All right, very good. Okay, lights on.
Hey Dan, can you hear me? It's
I
Adam.
can.
Wow.
Hey,
that's
Adam,
cool.
how are you?
Good. How are you?
How you doing?
Good. You
I'm
getting some
doing
selfies?
really well. Yes, we were getting some selfies of Jason, just like we did at Havre, but this time with lights. So the images are pretty good. Did you see the couple that I sent back the other day?
I haven't looked at them yet.
I know, that's because you don't read your email.
There's a lot of emails to read.
I know. No, we've gotten some really good imagery. The pilots have been doing a great job with that, and yeah, it's as you know, quite picturesque. So yeah, so we've been doing pretty well here. We're just getting set up to. You can go ahead and turn off the lights now, Chris, on the elevator. Okay. So we just finished doing some sampling at Tica, and we're about to release the elevator to the surface and then go up to Q and M vent for some more work on this dive today.
So our fluid temps are warming up. Is that what I heard you say?
Yes, yeah. Thibaut has been keeping track of what we've been telling him in terms of the actual temperatures that we've been measuring at the vents from Jason. Believe it or not, I've been so crazy busy that I haven't had a chance to actually look at the logger data from the 5 loggers that we recovered. But we definitely have hotter temperatures than we did 15 months ago when we were last here in December of 2019. So and things seem to be on a trajectory. Jill, maybe you can remind me, or Thibaut, if you're online. You know, it seemed like it was heading for about 2023 when it would start to intersect at least the previous kind of temperatures that we have experienced in 91 and 2005, 2006.
Mm-hmm. Cool.
Yep, I
Okay,
can
Chris. So
confirm that's what Thibaut is predicting. I don't know if he's on. It's pretty late in France.
yeah.
Hey, Jill, how are you?
Hi, Adam. I'm doing well. Thank you.
Oh, look at the cute little Galatheid crabs.
For those of you listening, Adam Sewell is a volcanologist and someone who's worked a lot here at the East Pacific Rise with me since he came to Hui. How long ago was it, Adam? 15 years ago, 18 years ago?
Yeah, something like
17
that.
years ago. Hard to believe. And is now going to be at the University of Rhode Island, a professor there in the
Graduate School of
GSO.
Oceanography. Yeah.
There you go. Yeah. And also as the director of the, I can't remember, what is your actual official title, Adam, now?
Yeah, director of the Ocean Exploration Cooperative Institute, which is a NOAA cooperative institute focused on developing technology and executing ocean exploration.
Great. Yeah, lots of opportunity and lots of challenges, but definitely something which in terms of 21st century oceanography will have a lot of sort of far-reaching potential because there's still a lot to be discovered for sure.
Absolutely. Who's piloting right now?
We have Chris Judge in the pilot seat and Nick Osadskia, the Alvid pilot in training, is the navigator. And actually we have Ronnie Wims, who's the bosun on Atlantis, helping the Jason team out, which has been
so
great.
cool.
So yeah,
Tell
we've got
them all I say hello.
great team. Adam says hi. Yeah. So we've had most of our dives. We have ops pretty much ending in about 4 days before we have to head back to San Diego. But we've gotten a lot done. Lauren Molyneux and their team, the biologists, have been making a lot of progress in deploying their instruments or their sort of colonization panels, and they've been doing a lot of work right here at Tica and at Riftia Mound, just south of here. So yeah, we've done very, very well. We've had this is now, I can't remember, I lost count. I think this is our 7th event that we've instrumented. We have Q that we're going to do later on this afternoon, but we went all the way from BioVent M, and now we've got Tica, and then Bio9 P, and V, and L, and L hot. So we will have 8 or 9 events that we've instrumented in terms of trying to look at the temperature increases and changes in fluid chemistry here in what we expect to be the run up to the next eruption that might happen in the next few years.
Have you picked up any rocks?
Have we picked up? Yeah, I did pick up a couple of rocks. I was proving to somebody about the drip structures, and you know, I have a rock in the main lab that's got these beautiful drip structures in them. Right. We haven't been doing a lot of rock sampling. We've been mostly doing sulfide sampling, although just the other day at below M vent, we picked up some great stock work. Jill and I were noodling around below the vent chimney and saw this sort of vein coming out that was very different than the volcanic talus, and so we were able to collect that, and it's a really spectacular sample.
Cool.
Yeah. So hold on a second. I've just got to talk with the pilot for a second. So
I'm going to go on mute. Yeah. Hey, it was great to hear your voice, though.
Thanks a lot, Adam. Great to hear yours too, and miss you out here. All my collaborators, Rachel and Adam and others. Yeah, it's been great using the Zoom session and the expanded bandwidth to do this. You know, it's been very effective, and we've, I think, had a lot of people sort of looking in or checking in to the room, and especially on the YouTube link.
So cool. Great job. Talk to you later.
Thanks. Yes. Hi. What does it say? I can't read it.
Do pilots need to log a certain number of dives with Jason before piloting it out?
Before piloting Alvin. Okay. So I guess I'll try to address that. So there are pilots for Jason, and there's pilots for Alvin. I think there's a couple of things that are pretty important in thinking about that. That the folks that pilot Alvin are also people who maintain and operate that vehicle, just like the pilots who operate Jason know a lot about this vehicle system. Because Jason is a tethered system, we're attached to the ship by a fiber optic cable. There are some very distinct differences in the actual vehicle characteristics and how it's, how it is configured and put together. So they have to know a lot of those kinds of details. I would say from my experience, there are many of the pilots that have been working with Jason that have ended up being Alvin pilots. They started out as Alvin pilots, and then they sort of transitioned to the ROV team. But just because you've been piloting Jason doesn't mean that you can pilot Alvin. There's a very specific set of procedures that have to be followed for Alvin pilots. And in fact, Nick, the navigator here, is a pilot in training. And I don't know, you want to say a couple of things about what it takes to do that? No. He's being shy, but basically, the Alvin pilots in training have to go through a very rigorous training in knowing everything about the vehicle, because when you are piloting Alvin, you are the single pilot. It's the only deep submergence vehicle in the world that is piloted by one pilot and has two observers in it. Most of the other ones have two pilots and only one observer, so we're being much more efficient from a science point of view in terms of getting more people to the bottom and doing work with Alvin. So that's why the Alvin pilots need to have a very in-depth understanding of every aspect of the vehicle system. And that takes several years to do. And they also have to have a certain number of practice dives where they go down with another pilot who is a certified pilot, and that's called a pit dive, a pilot in training dive. And those pilot and training dives are critically important for training the sort of next generation of Alvin pilots. In addition, they have a lot of homework to do in terms of studying all of the details in terms of the electrical and mechanical systems of the submarine, and that's something that also takes an extensive amount of time. And finally, they have to pass a number of tests, both written tests, oral tests, and practical tests, meaning they have to go on a dive and basically do everything themselves. So it's a very rigorous process and takes a lot of time. Similarly, for Jason, the pilots are often either engineers or mechanical engineers or electrical engineers that take care of the system. And many of them actually start out simply maintaining the vehicle, but then over time get some experience in piloting and in running the manipulators. And so it's a very similar kind of approach where they learn all about different aspects of the system, and they get a chance to actually drive it and practice how to maneuver around and do the kind of operations that the scientists require of them. So for both vehicles, it's a very rigorous process, and for both vehicles, it's something that takes several years to sort of work into. But just because you're a Jason pilot doesn't mean you can be an Alvin pilot, and vice versa. I hope that answers the question, and sorry if it was too long. Okay. Thanks, Chris. Yeah. Oh my God, what is stock work? I'm gonna let Jill answer that one. But it's a rock type, and it's a description of a particular rock that is found in hydrothermal systems. I am not actually sure if it also relates to other environments, but I'm most familiar with its usage as sort of the underpinnings or foundation of the sort of host rocks underneath hydrothermal systems. But Jill may have a more specific and technical sort of description of stock work.
Hi, Dan. That was actually pretty descriptive. The way I think about it is it's the plumbing system that underlies these vents. And so it's a really useful sample because otherwise we don't really know, we don't have a physical sample very often of the plumbing network below the vent, although it's really very interesting in terms of a chemical and mineralogical environment. And so instead, what we're usually kind of limited to is inferring what those processes are based on the fluid that we can collect at the seafloor. So what the stockwork sample allows us to do is to understand at least the shallow subsurface that's underlying these vent systems.
Great. Yeah, no, exactly. That's, I mean, that's, you just made a very important point. It gives us a window into those processes that you otherwise don't get from just sampling the fluids. And these kinds of deposits, many copper deposits on land where they're mined, some of them certainly were ancient hydrothermal systems, and that's why there is a whole field of industrial, if you will, study of hydrothermal vents and vent systems, and exploring their potential as possible deep sea mining sites. I won't get into the details of that. I have my own particular views of that, but certainly it's something that is it's interesting from a research point of view, and the extent to which it becomes a practical a way to extract minerals from the seafloor, and whether that's something that's a good idea to do is I think currently being debated, both in terms of hydrothermal systems, and some people may be familiar with with manganese nodules, these deposits that basically are found in very deep parts of the Pacific Ocean, in the sort of central and northeast Pacific Ocean, where you have a lot of the minerals that are concentrated in these nodules that form in the particular deep sea environment. And some of those have quite high contents of nickel and certain types of metals, in concentrations that are much higher than deposits found on land. But the problem is they're at the bottom of the ocean. So question is how viable is it to bring them up to the surface but find them and bring them up to the surface in enough quantity where it's economically viable. And again, that's currently a much debated topic. Okay, what you see here is us doing a bunch of housekeeping. We're swapping out these samples because the vehicle has a tough time carrying all of the bottles that maybe we would like to use. The basket space on the front is somewhat limited. The elevator is a way that we can bring samplers back to the surface and switch out with other ones. So the ones that Chris is just housed in the manipulator, that bottle number 5 is the one that we're going to use up at Q-Vent. So it hasn't yet. And he's holding in his port manipulator the one that he's going to stow on the elevator, because we're going to send that back up to the surface for recovery, so that we don't have to carry it with us. That will allow us to be a little bit more flexible in terms of where we drive and how we drive to go up to Q-Vent to do the rest of the work. Okay, Jill and Ross and others, I'm gonna, while we're doing this bottle swap, I'm just gonna step out for a second and go get a sweater because I'm freezing in the van, and I will be back shortly. But we've probably got, from when we finish doing this bottle swap, and then the elevator's got to get to the surface. So we're probably looking at about an hour and a half or so of this kind of operation, and then finally heading up to Q-Vent. For Javier and Nuno, we're doing water sampling at Q-Vent first, and then ending with the imaging work at M-Vent, and also we have some potential fluid sampling that we want to do at M once we get to the top of it to look for this diffuse flow that Jill is interested in. So I'm guessing that it's going to be towards the end of the dive. We are supposed to surface at midnight. I'd like to try to keep to that schedule because the biologists are expecting to dive at 4 in tomorrow morning for a series of 2 dives that they need to do to complete laying out their experiments for their time series. So we'll have to see how far we get. We have another dive at least after this, possibly 1.5 dives. So there's going to be another opportunity for sure to do that. So I think for now, we've got about an hour and a half or maybe a little more of housekeeping and elevator recovery and whatnot, and then we'll be heading up to Q-Vent. And I think then at the end of the evening, our time, early morning, your time, Nuno and Javier, will probably be at M doing the imaging work if we can get there.
Then, sorry, then you have an idea, you said 1 hour and a half now, and then some other time, do you know more or less how much that other time will be? So more or less an estimate from here until starting the imaging?
Well, I'm just backtracking it from when we're supposed to be on deck. We have to leave the bottom, to be on deck at midnight, we have to leave the bottom at 10:30 p.m. It is now, let's see, remind me everybody, what time is it now? It's 3 o'clock. So it's 3 o'clock in the afternoon right now. So I've got about 7 hours. If I back up from when the elevator is going to be on the surface and I'm free to go north, I'll have about 5 hours. I suspect that it's going to take us maybe 2 hours or 2.5 hours to do Q. And so I'm expecting that perhaps the last 2 hours or so of the dive will be up at M. That's sort of the best I can do right now. So that would mean that it would be approximately, let's say 8 o'clock p.m. My time. And that means it's in the middle of the night, your time. So so that's about the best I can do for an estimate, Nuno, at this point.
Okay, great, thanks.
Okay, but I will update you, and if Javier is around, we'll make sure to let you folks know how we're doing, and so that you can see if it's possible for you to be up and help us when we're doing the imaging at M.
Okay.
Okay. All right. I'm going to step out for a second.
Come back online in like 4 or 5 hours.
Yeah, sure. That sounds like a plan. Okay. All right. I'm sure we'll be in touch later, folks. So Jill and Ross, and I don't know if Thibaut's on too, but I'll be back in just a few minutes. And by that time, hopefully they'll be done with the bottle swap, and and they'll send the elevator up. Chris, you're going to release it mechanically, right? Manually? Yes, please. Yeah, and did you take all the weights off? Good. Okay, so we don't have any more weights in there. Great. So it ought to come up pretty fast. Okay. All right. I'll be
Thanks,
back in just a
Dan.
few minutes.
Thank you.
Yeah. Okay. Thank you all. Thanks.
Thank you, Dan.
Hey, Jim. This is a bit of a shout out to Jim Casalos, who just joined the call, and he is a longtime friend and colleague. Actually, he was a graduate student when I was in undergraduate school in the University of Wisconsin in Madison, and Jim got his PhD there in geophysics, and has done a lot of work. He's basically an electrical engineer and a geophysicist, and now runs San Cristobal Coffee. So anyway, Jim, great to hear from you.
Hey, Jill, you there?
So you were gonna be on Zoom call or something?
Okay, this is Dan back again. What do we got here for the elevator depth? 900 meters. Okay, so we're expecting the elevator to be on the surface in about 20 minutes or so, and hopefully recovered maybe 15, 20 minutes after that. So we're sort of on schedule. We had hoped to be able to be free of the elevator and able to transit north by 5 p.m. It's now about 4 p.m. So we're doing pretty well. And we're just hanging out here above the seafloor, a few tens of meters, so that the ship can maneuver. And where is the elevator heading? North?
Yeah, north.
How far? Oh, that's good. Well, it's going in the right direction at least, because we want to go north too. So we'll end up being north of Tica. No, actually, we'll end up being, well, it ended up going pretty much east and a little bit south. So we'll end up in more or less the same spot. So from where we pick it up, Akel, we can probably just traverse over the east side of the actual trough wall up to Q. That's fine. Got it.
Hey everyone, this is Zoe Yin. I'm one of the students on the cruise here, and I'm in the van. And while we're waiting for the team on deck to recover the elevator, I thought I'd show you guys a couple pictures of what it's like here in the van. We can't turn the camera on to show it, but I've just pulled up a couple of photos that I took on my iPhone. And here we have a picture of Nicole, who's normally on watch right now, but she's downstairs helping process the bottles that are coming up on the elevator. And she's talking with Akel. So this was on our last dive. She was launching some arms to recover on the next dive. And so she was helping decide on the placement of those arms for her experiment. And here's a photo of kind of the setup. So this is the view that I'm looking at right now, which is kind of from the back seat. On the left, we have the computer where we take notes about what's going on during the dive. So these are notes about, what's going right, what's going wrong, what temperatures we're seeing, anything that we might want to reference later when we're going back and trying to interpret our data. In the middle back, we've got the navigation map where we can see kind of a bird's eye view of where we are relative to the trench and where all of our equipment is, so like kind of where the boat is, where Jason is, where Sentry is. And in the front is you guys as YouTube and Zoom. And then on the right-hand side is where we have our video logger sit. And this is someone who kind of turns our 4K cameras on and off and kind of decides what we're going to record in these really high quality images and videos that we can then take home with us. And then in the front, you see Dan with his headset on. So that's how he's normally talking to the other collaborators. And also talking with the pilot. So up in the front, you see the three Jason folks in the middle, our pilot on the right-hand side, and the left-hand side, some other supporting folks. And then the array of screens in the front are showing all the different views and all the different data that's coming in that help them kind of get the context that they need to drive Jason. All right. Let me see, I think I just included some other random photos in here too. Here's Connor and Billy's processing some of the IGTs after they come up to the surface. This is actually probably what they're doing right now. As the elevator comes up, they're going to pull all of those bottles off the elevator and start to process them. Another view of the van here. And then this is a view of our main lab. This is kind of the central place that we're hanging out during the cruise. We're looking at our data. The biologists usually use this long table to process and dissect all their samples. And it's where a lot of the conversation and organizing happens for the trip. So here, this is kind of on our transit to the EPR. And we're having a science meeting. We've got a big map of the EPR out, so we can kind of look at all of the sites that we were thinking about visiting and talk about our science objectives and make sure that we were all on the same page. Okay, well, that is all I have, and we'll be back in a second when we get the elevator on deck and start transiting to QVent.
Hi all, it's Dan. I'm just back in the van after getting a bite to eat. Zoe's gone to the mess deck now. We're proceeding up to the northwest, flying just east of the east rim of the axial trough, and we're. Can you zoom out for a second, Hugh, just so I can see where we are? Right, so we're basically about 100, 200. Oh, that's good. That's good. Yeah. And move the whole map down, please. Yeah, that's perfect. That's great. Thank you. All right. Yeah. He's gonna have to come. He's gonna have to come west. So we're now about the ship is almost to the to Q vent position, and then the ROV is going to catch up to it. We've got another 250 meters maybe to go. So we're going to have a look at this vent and the chimneys up on top and see their suitability for sampling. We looked at them yesterday or the day before yesterday, and there's definitely good venting coming up the off the top. A lot of very strong diffuse flow off the top of the structure, but the orifices are quite small. Jill, if you're online, could we have a conversation for a minute?
Hi, Dan. It's Jill.
Hey, Jill. So this is probably a good time to chat about this so that you can make the best decision. So right now, I'm at a point where if I want to go up to M to be able to measure temperature and maybe fire this bottle that we got, the IGT, to determine whether in fact there is the right flow up on the top, now would be the time to do it. But if you want me to start at Q and sample Q, and then we just reserve a bottle, I can do that too. So I think we need to make a decision about that, just because it's going to be easier in terms of how we deal with the vehicle and ship sort of navigation placement.
So wait, so is the question whether we want to go to Q next or to M next?
Well, if you're set on wanting to know the temperature at the top of the old M vent structure, and if there is sufficient flow, then it's probably time to do that now, rather than go to Q and wonder or hope that it might be the right temperature, I guess is what I'm saying. Right? Because that's
okay.
the big question that we've got.
Yeah, I would.
Okay.
If it's possible, let's go over to M next. But I'm also okay with taking the gamble if it's better to go to Q. Yeah, but
well, if it's an important sample to take, then I think, you know, we're doing a traverse, or we're sort of in traverse mode now. I can position the ship so that Jason can get to M, and then if we decide that there isn't sufficient flow and it's not what we want, then you know that you would go ahead and fire the bottles at Q and we'd be done with it. I think.
That's right.
Is that true?
Yeah, that's true.
Okay,
exactly.
so Akel and Hugh, if you don't mind, a change of plans based on what Jill and I just talked about. I think we're going to go to M, and go to the top of the old structure. When you were helping Nicole yesterday place the stuff around the base of M, of the old M vent structure, we want to go to the top of that structure and see if there's venting, and if so, what temperature it is, and we'll use the IGT to measure that. And if it's not a good spot or not what Jill wants, then we'll go back down to Q, do the fluid sampling, and then we'll come back to M and do the imaging. Okay. So sorry for that change of plans, but I feel like it's probably better to set up and do that now, because otherwise it's a hope and a prayer that M vent has got the right kind of fluid or the right temperature. So I think it's better to do it now.
Thanks, Dan. I'm very excited.
Okay.
You know me, this is my favorite fluid.
Yeah, I know.
I hope it's venting.
Well, I guess I mean, the indicators we have is that there is flow up there. I just don't know because there's bacterial mat up on the top. I just don't know whether there's sufficient flow or what temperature it's at, because I don't think we've done a very good job of measuring that. We've been more focused on the more active vents, which are just to the northwest of the old M vent structure.
Right. Is the old M vent structure sort of the first one? Remember, there was a line kind of different venting structures. The old one is the first in that line.
The old one is is southernmost, exactly. And then there is this ramp. There's this rampart, and actually, it's pretty well imaged in the Sentry bathy data on the inside of the trough, eastern trough wall, or the eastern side of the trough. There's this big rampart, and those M vent structures are all built along that rampart.
Okay, got it.
And that's the other reason why I felt like it would be great to try to do some lateral imaging of that, and sort of as the vehicle is pointed towards the vents and just lateraling along them to try to build a mosaic of the structures for us to be able to get that sort of perspective of how they're arranged next to each other.
That would be very cool. I agree.
So can I ask a question? Is there a reason why I'm only seeing one of my probes there? Okay, it is there. Okay. It's back. I see. Yeah, I see. It's back in the tip, right? But you guys sold it to some fish. So how did they get the fish on the last dive? They sucked them up? You slurped them. Wow.
So I was just talking to Carolyn, and she said they got all the parasites off the spot lobster. Yeah. These all pumped, and the fish were in great shape. I don't know.
Uh-huh. So was that in the single chamber slurp, or did the multi-chamber not work? The multi-chamber. Oh, good.
We cut at least one in half.
In the slurp? Oh no! Oh, I don't want to hear that. No. That's definitely nightmare material. Okay, we're about 300 meters or so southeast of them. And you've dialed us in at 5 at half a knot. So the ship is going half a knot. And where are you planning on stopping us, Hugh? I guess I was.
You want to go further east?
No. I don't want to go further east. I was thinking that having the right side of the donut be basically parallel to the east wall. That would be, and I don't profess to understand the donut theory that well. What's that? I don't know. That's what I'm wondering about. In other words, that gives us the ability to go down the wall a little bit and to go up and down. In other words, if you have the right side of the donut, if that's parallel to M vent and the east wall there, seems like you're able to maneuver that whole area, right? with the middle of the donut sort of over the middle part of the trough, or maybe a little bit to the west. Yeah. So that would be the middle.
Okay, so do this. So you want this part here,
Yeah,
and this part is going to be
over there, right?
So
Because I'm mostly focused on the east wall right there. What the diameter of the donut? Mhm.
or the radius. Dynamic.
Yeah, well, that's right,
Yeah.
because you can change it by moving the cable up and down.
Yeah, I'm just trying to get some benchmark distance.
But I would, from where you are now, I would start moving the ship west a little bit, or to the northwest, right?
So we're going to slow down and it's going to kind of swing in.
Well, where's your target?
Right here.
Oh, it's heading for that spot?
Yeah.
Yeah, I would say that that's a little too far north.
You're gonna, it's gonna, eventually, what you want is the ship to be, it's gonna stop there, so in the middle.
Oh, so that's why you were saying to work on the west side of the donut. Is that why you're saying that,
Yeah, I
Kel?
mean, just,
It doesn't matter, I think, right?
no, but, you know, for, if the wall is pretty steep and stuff, it's probably best to have the cable.
That
deep side.
on the deep side, right? Right.
That works, working the east side of the donut.
Yeah. Okay. All right.
That's gonna be down in the crevice a lot.
Well, we're going to be we're going to be west of the margin a little bit, right? We're not going all the way down to get like the stockwork like we did, but we're going to be down a little bit from the margin. So I would say you put this part of the donut so that it covers this area right here.
Oh, okay.
Okay. So that means the ship's
means
got to
we
get
gotta
here.
go west.
That means you have to go west. Yeah.
Okay. Yeah. It's pretty close to the original.
So you're seeing the margin of the trough here, the east margin of the trough, low baits on the upper right-hand side of the screen, low bait lavas, some collapse features along the margin, and then sort of sheet flow, hackly flows, and I know it's hard to see down in there, but that step in the upper part of the wall is probably 4 or 5 meters.
So when it erupts, is it sudden or is there a swell?
Tim, if you're on the call now, you can unmute and we can have a brief chat about what we did at Tica and what we're going to do.
Kilometers, you actually see like 10 degrees, 20 degrees? No.
No.
More like 1 degree, 2 degrees, 10. Yeah, building up pressure.
Good. Hi, Jill. Okay, so can just stop right here for a second. So can you do a 4K video? It's already going, great, okay. All right, so this is what I'm talking about. Here, you're looking at the old M-vent structure. And you're seeing that rampart with all of the bacteria on it and the little chimblets in the middle, right? And then you're and then we're heading sort of east right now. So we're looking at, on the right side is the old M-vent structure, and on the left side is the other vents associated with M along the east margin, just inside the east margin of the axial trough. And you can see that there's stuff down low, there's stuff up high. Those selvages that you see, those lava shelves that you see, that's 2005, 2006 lava, right? Up there that went up part way on M, right? And we visited M in 2018, and there wasn't nearly this amount of bacteria on there. We can go back and look at the photos, but and that's the top of the old M-vent structure.
Dan,
Yes.
That looked
Okay, get me good.
Oh, sorry. I mean to interrupt you.
No, sorry. Kel's just needing to navigate around and get himself oriented in terms of the ship position and whatnot. We're heading east. So now you're looking directly out to the east, right, along the east margin, old M-vent right there. And there are a couple of other chimblets just a little bit south of there too, those little guys right there, right, which I had never seen before. And it looks like they're sulfides built on lava pillars to me. I mean, certainly the basal structure looks like lava pillars.
Yep.
Yeah.
But we could see them.
Yeah. You just tell us, Kel, whenever you're happy with where the ship is and what you're going to do. But I think you see the lay of the land there. That's sort of what we were trying to do. Okay, so Jill, what is your plan in terms of going to the top of M-vent? We're going to get the IGT and we're going to use that to prospect for temperature, right? Or do you want us to make an orifice first, depending on what we see?
I think we'll probably be prospecting for temperature. I'm hoping there'll already be some areas that are venting. I looked back at Jeff Seawald and Stefan's cruise in 2014. I know it's changed since then, but they definitely took a sample from a naturally venting fracture at the top of the structure.
Okay.
They didn't have to root around, from what I could tell.
Okay. All right.
Yeah. But also, FYI, it didn't look like much visually. It was pretty unglamorous looking.
Yeah, right.
And it's definitely like a clear fluid that's you have to get your eye in to see.
Right.
Just like a white stained, unassuming crack in the top.
Great job, Zoe. So that's a spectacular view of the collapse here that you can see through the stratigraphy and all of the selvages, the collapse selvages in the inside of the lobates on the east margin of the axial trough here. So Akel's just flying east a little bit. He's needing to get himself properly oriented with respect to where the ship landed and where we've got the cable. So just going to take a minute to get sorted out. But in the meantime, we're going over some pretty spectacular collapses, and I'm sure the downlooking photos are going to be great. And Zoe's doing a great job on the forward camera. Are you still recording 4K? No. I'd stop that. No, you're not starting it. But the key thing that I'm looking for is when we're doing those pans, even if we're not using it in a quantitative way yet, we'll want to capture those because they give us great contextual information. Okay, there's Nicole's little lander. Okay, I mean, so here we're oriented 315. There you see part of Nicole Patour's experiment with the arms panels, and there's a little larval trap and a sandwich next to it, next to the old M-bend structure, which is almost directly in front of us. So Kel's sort of circled around. Now he's heading almost about 315, 310, the northwest. So we're on the east side of the old M-bend structure. And he's on the sort of the fat part of the donut. Is you still moving you over, or are you just trying to? Okay. Yeah, okay. It's important for the vehicle and ship arrangement to be good, because otherwise, if the ship starts yanking the ROV just as we're getting set up to do delicate sampling, that's frustrating, to say the least. So better to do the setup, take the time to do the setup, and then get positioned for making measurements and doing sampling. I was just showing the ROV team and the observers here some of the initial results from the imaging elevator that came back with the water sampling bottles, and the pictures look pretty spectacular. I think we did a really good job of capturing the vehicle as it was sampling and moving around the hydrothermal features there at the Tica vent. No, that's right. No, not yet. So right now we're heading 270. Kel just went over to the other wall, doing a little sightseeing here in the axial trough. The vehicle's at 2505, and we're about 5 meters up to 2510 down to the seafloor at this western margin of the trough wall, and it's about 50 meters wide. You ready to go up to the top? Okay. Oh, I see. You were moving the vehicle to sort of drag the cable over. I see what you're saying. Yeah, yeah. So maybe I should bring my back massager in here for you guys. Just put it right on the back of that chair. What do you think? Have you guys fall asleep while you're piloting? Right. Bless you. Okay, we're moving back to K vent. To M vent. Cable now is in a pretty good position. We've got the donut centered right over M vent, and we're going to go up to the top and prospect for fluids. Jill said what she'd like to do is once you get on top, is get the IGT in the manip, okay, and we'll try to get that set up so we can use that to figure out about where to take the sample. Sorry, say again. Top of the vent. We're going to look at the top and we'll see what we see there. Yes, yeah. The other reason is because it looked like there are some small chimlets at the top. And whether they're just diffusing now or not, whether if you knocked one over, you'd actually get some more focused flow. What's that? No, because it's a pretty crappy image. Thank you. The other pointer is it right there? Yeah, I think so. Yeah, so that's part of MVET there. He's now pointing to the southeast. So we're now looking at the old MVent structure. Let me just verify that that's the truth. I'm wondering if this is the, yeah. Okay, hold on. Let's see. No, I think this is the one further north. I think the old MVent is to the right, Kel.
I don't think so.
You don't think so?
The invent with your logger in it?
No, the MVent with my logger in it is to the right. It's to the left. You think? let's look because let's just pan to the right. Okay, well, just pan to the right first. Thank you. Yeah, okay. But you see, hold on. Yeah, that's hold on, let me just get oriented here. So let's go parallel to this for a second. Let's go straight if you can. Sure, yes. Yeah, go ahead and record 4K. And Zoe, you can try to twiddle that a little bit. Okay. So as a start, now I want to look at this stuff down there, that stuff right there. I want to see if that has those shelves in it. Yeah, it does. So this is the old M-vent structure that we're looking at right now. Okay. And so that's the old M-vent structure because these are the classic little shelves that we've seen for now years. And now if we turn left, we're going to head more north. This is the lineament right here, and there is our logger, right?
That's the big sandwiches.
Oh, these are the big sandwiches. So where is the logger? And is further south, further north. Okay, so we want to go to the top of this one that's right in front of you. Okay, and we would like to look because it seems to me, Jill, as I'm looking at it now, there's a smoker right there behind on the other side. Turn the ISO down a little bit. See that, Jill?
I do.
So
yeah.
so there's definitely activity up here. How easy it's going to be to go and get it, I don't know. Yeah, focus and then pan out a little bit so we have context. Okay, that's good. Yeah, that's great. The focus is good. Okay, so
Yeah.
okay, yeah. So give Jill a view. Okay, so you see that, Jill, out a little bit more, down in the ISO a little bit more. Yeah, like that. Perfect. Okay, that's great. Are we recording 4K? Yeah, we are. Okay. All right. So that's the old M-vent structure, and this is definitely more active than what we've seen.
It is. Yep.
Yeah, and I'm guessing that we could have Akel do a little bit of housekeeping here on some of those chimlets, and I'm betting that we would get some focus flow out of those guys.
I think so. We have some nice little chimlets right in the foreground here.
Yeah. Yeah, no, he's just pushing my logger back, so it's not in his way. Okay, that's good for focus. Okay. Right, take a snap too. Oh, you have been? Okay, that's great right there. So we're right now we're heading east. Okay, so this is the west side of that structure. So that little chimlet that's smoking, the black one, is sort of on the north side or the northwest side of the structure. Do you think that you could set up right here, Akel? Like,
Doesn't look great. No. I think I'm gonna try to come around the other side and see if I can get it.
you can't. Can you just lateral around to the left here? Okay, let's lateral around and see what we get. Yeah, this is definitely more active than it was in 18, and more active than I think it was in 19 for sure. Although I wasn't on a dive that went here. You getting some snaps of this too? Right now we're coming around and we're heading almost 170. Yeah. Now we're almost heading south, so we're looking at the north side of the structure right here. Right. So that's what we were talking about, Akel, is whether you could get to that guy. Because that seems to be the most active one right there. I mean, I think down here it's pretty solid.
Right under me. There's little chimneys.
Yeah.
There's that behind.
Yeah. Fine.
So it's
Oh, that guy. Hi. Right. Okay. I mean, if you get closer to that guy. Yeah, that's where we want to try to take a sample. Focus, focus. Okay. A little bit more. That's good enough. That's fine. Good. No. Stop. Leave the focus alone. All right. And I would say turn the ISO down a notch. Yes, like that. Perfect. Okay, that's what we want. We want to be able to stick the IGT in that, even before you do anything to it. So are you guys ready for IGT? Okay. So Akel's gonna try to get set up here. This is not an easy setup. He's up. Well, it says 1.6 meters, but he's actually more like 6 or 7 meters up off the ground below him. Yes. You don't have temperature? Yeah, hold on. Jill, I'm going to have you be able to talk to Keldon. She's working the computer, okay, with the IGT. Hold on.
Hi, Jill. Keldon here.
Hi, Keldon.
Hi. So we have the IGT up and running, and the battery voltage looks. Yes. Hi, Joe. Okay, yeah, sorry. So we have a battery voltage, but we do not have a temperature reading.
All right, what's the battery voltage read?
13.2.
Okay, that's good. And are you seeing it pinging? Does it say hashtag WB1 over on the left side of the software?
Yes.
It does.
Yes.
And what's it say instead? What does it say? Does it say the 273?
It says, no, it says -1 # J degrees Celsius. Oh, we just got a temperature for a millisecond, but it's. But yeah, I don't think we're going to get.
We had pretty poor comms on it earlier, Keldon, but there were some good temperatures.
Yeah, I have Billy here, and he said he was working with the cables earlier. I switched out the cable directly connecting the ICL to the computer, and it's giving the same issue. And Billy's working with the cable right now, but it doesn't seem to be. Are you switching out the connector? We do have ICL1 on the basket in a different location. Oh, okay. Can we pull up the temperature readings for this on this computer?
What's that? What's that? The ram is, it looks like the pin is sheared again. You see how it's cattywankers? The bolt? Okay, do we have anything on, we have any temperature?
I can try and flick the thing with the other arm.
Well, do we have a temperature reading first? Do we have any temperature? Can you just wiggle the ICL a little bit? Do we need to come down? Yeah, we need to come down. That's too much space. Okay, how about now? Okay. Yes or no? Okay, all right. So let's go ahead and use that.
We're not firing it, right?
No, we're not firing it. No, we're just taking a temperature, right?
Dan, if we get a good spot, we can fire it.
Yeah. Okay. We'll get to that in a minute because it seems like the paddle on the Tom Thumb is a bit askew. So if we do want to fire it, Kel's going to have to do some funny business, perhaps.
Oh, I see what you mean. Yeah.
Okay. Unfortunately, the pilot camera has the best view of this. Once you get it positioned over that orifice, Kel, I'm wondering if you could also point the port arm to it so we could get images that way, because the okay, can somebody start reading temperatures out? How about now? Okay, just read them out, please. Yeah, it looks like you have to go back a little bit. You need to go into the screen a little bit more. If there's an orifice, it's that way. Well, let's try. What's the temperature? Yeah. Okay, good. Stop, Akel. That's good. What is it now? Oh, you don't think that there's an orifice in there, huh? Right. Okay. Yeah. Yeah. Right. Can you? Yeah. Can you put it right there and just see what we get at that flow?
Dan doesn't trust me.
No, I think you can see. Sometimes you see different things. What's it? What do you got for temperatures? Yeah, now. How about now? He's right on it now. Nothing? Yeah. Okay, just hold it there. 62. Okay. Okay, so maybe it's a case where we need to knock that puppy off. Can you, while you're holding the bottle on the right, can you bring the left arm around to get that thing? What's that? You don't think we're gonna core it? You're gonna just slap it with the side? Yeah, okay. All right. But go down to the base if you're gonna do it. Okay, yeah, don't core with the thing. All right, that's good. There you go. Now we're talking. All right. Now that's, yeah, stick it in there. What temperature are you? 74, hold on. That's a good. Unfortunately, the view you have, Jill, is not very good because of stuff across us here, but just how we're set up. But there's a very good view in the pilot cam.
Okay, Dan.
No, because he's resting on the edge of the chimney with it. It would change the setup. Okay, what do you got for temperatures? How about now? Yeah, louder. What is it? 72. Yeah, keep going. 185. Now? So that's an old one there, right? Okay, so it's an 8. So that doesn't look like. Did you move it a little bit? It didn't look like it. Oh yeah, okay. I'm guessing the snorkels aren't going to fit in there, right? No. It's hard to tell on this view. 150? 186? 180? See, it seemed like it was better closer to you. What is it now? 139. 189. You slow. Okay, stop. 184. Right, but it's still, you're still in a good flow there. Zoom out, Zoe. Let's just see what the bottle's doing. The bottles are venting very well. Yeah, okay. Try going in a little more. I know, yeah, I can tell, right? Yeah. Right. Yeah, it looks like the far nozzle is probably in it while the one closest to you is maybe only partially in it. How about now, you? Yeah, 199. Right there. So you sort of 220, 223, 207. All right. Okay, Jill. So you still there?
Yep.
Okay. All right. So I think we're clearly have fluids that are in the sort of 220 range here. This is cooler than M vent a little bit further north where we put the logger. Does anyone remember the temperature at M vent where we did the fluid sampling? 300 and some, 304 or something like that.
It was 335.
335. Okay. I'm sorry. Say again.
That was like max.
Yeah. Okay. Okay. So, all right. So now what, Jill? Now what would you like to see do?
I think I'd like to sample this one if we really think it's 100 degrees cooler than the other M vent. But it looks as
Okay.
though that's going to be tricky to do with the RAM right now.
Well, I don't think. Yeah, certainly the RAM right now is not terribly well situated. We could pick up the IGT and stick it in there, no problem. I think that would be easy to do. So if you want an IGT sample from this one, I think that's totally doable.
I would like a major sample or a majors pair and an IGT.
Okay, so you think you can make it so that you can take a sample with that guy? Okay, all right. So Akel thinks he can take a major with this. What's the temperature now? Okay, all right. So you haven't tried to put it in. What do you have to do to make it so that you can trigger it? And push it back? Okay. Okay, can we do that? All right. So we're gonna try to make it so that we've reoriented the tom thumb so that we can take the sample. And we'll use this major bottle and then pick up the IGT. And then, Jill, would you reserve the other major bottle for Q?
Yeah, that's what I'd like to do.
Okay. Zoe, can you zoom out a little bit, Zoe? So everybody can see what's going on. You take a 4K, please. Thank you. So we just need to rotate that with counterclockwise. Can't quite fit. Got to get the left finger in there somehow. Can you rotate the wrist and get in? There you go. You just made it. That's it. That looks better. That's good. Perfect. Okay. You done with the 4K? How much space? It looks like you have a space to get to do a couple of bumps, right? Yeah. You have to rotate counterclockwise, right? Yeah. That's good. Well, he's got to get the bolt underneath. That was what was hanging up. Okay. You getting temperatures or not? Okay. Okay. Yeah. Okay. Let's try to go in for the sample. Okay. For when you're sampling. Okay. Yeah, if you could get it in, even if it jerks, it's going to You still getting readings, you? So you can see that view in the middle of your screen, Jill. That's the one that we're going for.
Thanks, Dan. That's a better view. Thank you.
Yeah. Louder, Hugh. Eight, 8.3, 26, 54, 190. Man, talk about tailor-made. The nozzles are fitting perfectly in there.
It's a
What is it
beautiful
now?
fit.
12? Yeah, it's more like it. 239. 245. It does look like the bottles are 248. The bottles are venting. Nice setup, Raquel. 248. Oh, come on, Jimmy. What is it now? Yeah, just hold it here. 157. That's right. Just hang on. Hang on. I mean, I think that little piece may have been keeping some of the flow from mixing. 49? Oh, 149. Okay. Are you jammed all the way back against it, you think? Yeah. Well, it's right. I know it. It's just barely the width of the nozzles. Oh, I see. I see. Right.
I might be able to, if I swing it around so that's in front of me, I might be able to do it, but then we're not gonna have any view whatsoever.
Yeah, I think that this is a good setup, but so Jill, it's pretty clear that the fluid's hotter than what we got going in there right now. It's just that the orifice is so tiny, and it's complicated by having some overhang right above it, so that the nozzle is hitting the rock just above where it's venting. So I don't know that there's much that we can do here.
What's the temperature here?
Oh, hold on. You temperature again? 141. I mean, we did get up to, I think, 246 or something like that.
Yeah.
And what happens if you just try to jam it in there a little bit?
Let me try to get
Around?
the arm change the.
Okay. All right. Okay. We're gonna try to change the setup briefly, Jill,
Okay.
and see if you can get it better situated in the orifice.
Thank you, pilots.
But you can see how small it is. It's got a vigorous flow coming out of it, but it's really pretty narrow, and it's a little oblong, so that it barely fits the two nozzles together. But Akel's going to try to see if he can get a better orientation on it.
Thank you. Thanks, Akel.
Jill says thanks. You still getting temps? You?
Yeah.
And you can't rotate down at all, so you're angling them down. I was wondering if that might help. Yeah. What's the temperature now? Okay. Yeah. Okay. All right. Yeah, that's good. Okay. So can you just put this on my keyboard? Great. Thanks a lot. Is it typed up in it? And is it typed or is it handwritten? Okay, great. I don't have my glasses on, so I can't see it. Thanks. Okay, thanks. Got a temperature you? $81. 181. That's it. How about now? 188. Now? That looks great, Akel. 238. Yeah. 240.
Okay,
And the bottles are venting. I say we take
are
it.
the bottles venting?
The bottles are
All right.
venting, yes.
Let's take the sample if they're ready.
Okay, let's do it. Okay, watch the temperatures. Oh, you bastard. What is it now? 237. Okay, now. Can you jam it back in? Shit. What is it now? How about now? No. The springs are coming up, but it came out of the flow, Jill.
Yeah, I saw that. Just try to.
Yeah,
try
he's
get it
trying to
back
maneuver
in.
it back in. What is it now, you? 94. What is it? 79. It when we 172. Yeah, I think it's, but I think the springs are all the way up, Ben. Okay. All right. Well, yeah, I think the sample was somewhat compromised, but we, it when the plunger went in, it just kicked off a little bit of the back wall, and so it moved the nozzles out. Okay,
Yeah.
let's stow this one. So what's your feeling now? We want to take the IGT?
Yeah, let's do the IGT. We will not get temperatures on it, but because they're reading a voltage, let's still try to sample.
Okay. Okay, so we're. Okay, the IGT is next. Jill, can I ask you a question?
Yeah, Dan, go ahead.
Hey, Jill? Yeah.
Yep.
So just in terms of sort of prioritizations, do you, and knowing what you know about QVent and that it's likely to be not much easier than this, do you think that it would be better to try to take the other major sampler here rather
I
than
was
a
just
Q?
thinking that. Yeah.
I'm just
I think
just sort of
so.
I mean that's sort of my feeling too. And if it's acceptable to maybe at some point on one of the next dives that we have, even if it's on a shared biology dive, we could scoot up here and try to get a couple more double majors.
Yeah.
You wouldn't have gas data from Q, but you'd get, you'd be able to characterize the chemistry.
Yeah, we would still get the geothermal barometry from Q, but
Right.
I agree.
Right.
I think this is a higher priority now, especially since it seems, whoa, we all right? Seems
Yeah.
to be,
Yeah.
stop talking for a minute.
No, that's okay. That's all right.
You all right?
He's just we're fine. He just slipped off the ledge. It's not an easy setup at all, but
Yeah.
it's but anyway, so he's going to stow that bottle right now, and then the question for you is whether we try to set up again and do the IGT next, or do we do another major here and we try to do Q on another dive.
Yeah, I think we should take a second major and hope that second one's going to go better.
Right.
And then fire the IGT here as well visually.
Right. Okay.
And then
so
if we get Q later, we get it. If we don't, at least we've really sampled this one, done our best here.
Right.
Yeah.
Right. Okay. All right. Hold on a second. Let me go ask a Keller question while he's putting the bungee over. After you're done with that, Akel, let me know if I can chat with you for a minute. Not here, no. We will, but not here yet. Yes, we did. At Tica, yeah. Number 8. Okay, so let me ask you a question. Do you think that we could use the temperature probe to core it a little bit to see if we can't make a little bit better orifice? Jill decided she wants to do the other double major here and the IGT here, just so we try to make a more stable orifice for you when you go in for the other samplers. Okay. All right, so let's go back in and get set up. Yes, sorry. Oh, hold on, Jill. I'm gonna pass you to Keldon about some detail about bottles and sample bottles. Hold on.
Hi, Jill. Keldon here.
Hi, Keldon.
Hey, so if you want to do major samples after this dive, I just wanted to confirm that we don't have all of the sampling bottles left to take more samples.
Yeah. Do you have any Teflon bottles left?
I will have, I think, 1 or 2 more after this dive, depending on how much fluid we take.
Okay. That's okay. What you can do is, do you have any of the 1 liter Nalgene's that you used for seawater? Are any of those now empty?
I am filling them back up with seawater. We have or the Teflon ones are filled back up with seawater. The Nalgene's, we've emptied 2, I think.
Yeah, so in a pinch, you could use one of those because that's bottom seawater in there.
Okay.
So it would be like, just shake it out really good because the
Mhm.
fluids mix a little bit with bottom seawater anyway. And that they were acid clean bottles.
Yes.
Yeah. And then we'd have Connor do, probably maybe I'll have him take fewer Sipelco vials tonight so that he reserves some, like a couple for Q. And then you can use the 30 mil HCP bottles instead of the 15s. I think there's at least 10 or so of those left.
All right.
Does that seem okay?
Yeah, I
Great.
just wanted to make sure that was
Yeah. Yeah, that's in my mind. That I think the main thing is to make sure we have a large bottle that we can put a fluid in. Maybe we'll do 2 pairs at Q, but we'll have to see what the priorities look like and where we're diving to. We might also not sample it, so we'll see.
all right.
But,
Sounds good.
yeah, I think I'll tell Connor to reserve a couple of the Sipelco vials and then try to keep the 1 liter HDPE Nalgene's ready. As long as they're still clean and there's been nothing else in them, that would be a fine place to put the residual fluid, the big fluid that's left.
All right. Yeah, we haven't used them for any other purpose.
Okay, yeah, so those are fine to use. Yep.
Okay, perfect.
Okay, thanks, Keldon.
Yep. All right, I'll hand you back to Dan.
Thanks.
Hi, Joe.
Hi, Dan.
Yeah.
I bought Keldon like $13,000 of bottles and she's filled all of them. That's a good thing though.
We're gonna go ahead and do the IGT next. You're gonna do it with the starboard, not the port on? You can't get to it with the port? I'm just thinking what's gonna be easier in terms of your setup.
I don't need the RAM.
You don't need the RAM for it, no.
The thing with the port is it's gonna be blocking our whole view.
Oh, I see what you're saying. Okay. Yeah, well, if you can reach it. You've got the Tom Thumb RAM on the Lily gas type. Unless you can pick it up a bit out of the holster just by grabbing the T handle on the top. Okay. You see that you got the snorkel, right? On the bungee. You set up the sample? Yeah. Okay. Jill, Keldon's in the back, and she's got the laptop open and she's ready.
Okay, can we?
You want me to, you want me to hand the microphone to her?
Yeah, that would be good. Thanks, Dan.
Hold on.
Sheldon here.
Hey, Jill. The
Yeah,
so yeah, so the problem is the IGTs are big enough. The problem is the IGTs are big enough that he's having a hell of a time getting it in there. It is finally in there now. You can see the nozzle where it is with respect to the orifice, but he's having to do all sorts of weird maneuvers because the bottle is impacting the structure above where the vent is, just because of all the stuff on the bottle. So
yeah, it looks like a little bit of a funny angle. On a
it's it's a
but I
lot of
can
a
see
funny
that he's
angle, I think.
holding it in a different way than usual.
Yeah, right. Well, he had to try because we've got stuff on a basket that's getting in his way. The vent morphology just above the orifice is sticking out, and so it's overhanging it a bit. So it makes it hard for the bottle to just easily be able to fit in there.
Do you have a better view on the other cameras? Can you help be my eyes so that the bottle's not getting fried?
I don't think the bottle is getting fried. The bottle is not in any of the high temperature flow. It's just that the bottle is sticking into the surface of the chimney above the orifice.
Yeah. Okay.
That's the problem.
Yeah, it's just a geometry problem.
It absolutely is just a geometry problem.
Do you think?
Well,
I don't mean to be a backseat driver, like such a backseat driver. Would it help to use the other manipulator, or do you think it will not make a difference?
He tried to get it out with the other manipulator and he couldn't. Kel, do you think it'd be better to do it with the starboard side? Can you rest the IGT on the milk crate? Okay, so yeah, we're gonna try doing that. We'll put the IGT on the milk crate and he'll get it with the other manip. And that's what we initially tried, and we ended up getting blocked by the Lily sampler plunger. That then it was caught on the tom thumb. So it was.
Just be careful. Well, don't put all the weight on that snorkel because it'll bend it.
Right. Jill says just to be careful of the snorkel because if you bend the snorkel, that's going to be a problem.
Yeah, it might.
Right now the snorkel is up, so it shouldn't be an issue.
Yeah,
he's just trying to lay it. Yeah, he's just trying to lay it down so that the other manip can grip it relatively easily.
Yeah,
but it's snorkel up right now.
This looks okay. Yeah.
Lighten it so that Jill can see what's going on inside, even if it. What do you have for?
Iris.
Hold on. Okay. Now we'll move that. You see that? Okay, so that gives her a better view in there.
Yeah.
Okay.
Switching to auto consistently, so it's reverting.
Just on its own. Yeah. Yeah, more or less. Okay, you can stop it down a little bit now. Oh, look at that.
Nice.
A thing of
Perfect.
beauty. Not, I would stop because the last thing we need to do is to drop it over the front of the basket. Let's see if we can grab it there. Think you can have it well enough there, even if it's not in the groove? Okay.
Hey, Dan,
Yes, Jill.
do you see that cable that's in the hot fluid?
I do, but he's just grabbing it right now. So he's going to try to get it out of that hot fluid in just a
Okay.
second. Okay. Yep. Okay. He's pulled it away now and he's got the bottle.
Okay, thanks.
Well done, Akel.
Good recovery.
You still have comms to it?
Does Keldon still have comms regarding the voltage?
I just asked, do you still have comms in the voltage? Yes, she does.
Okay, good.
Zoe, zoom in, please. Right down there. Yeah. It's the front of the bottle that's preventing him from getting the nozzle in the right place. The front of the bottle is hitting the wall above it, and it's making it so that he can get within a few inches of the orifice, but not in it.
This, there.
No, I know. I'm totally with you. And it doesn't help if you go shoulder down and sort of elbow up. That's as close as we've been in the last 15, 20 minutes. Well done, Akel.
There we go.
Yeah, it's getting there.
Lights on a stick.
Zoe, keep it in, keep it zoomed in. Can I ask a question? Do you think that there's any value in trying to scrape that with a port manip to try to make yourself some space? Because the IGT is totally screwing up your, any chance you have of moving it so that it's close enough and giving yourself some orientation. You're like boxed in, right?
Well, everything's in the way.
I know. I'm
let
just trying
me-
to figure out if there's some other way to.
Let me just pull this shit out and maybe try to change my heading a little bit. Get that a little further away from the.
Jill, we're going to try to reposition because this setup is absolutely not working. It's an exercise in frustration. So just bear with us for a second here. Yeah. Yes. Okay, Jill, Kelton says she's getting temperatures.
Really?
Hold on a second. I'll pass you over to her.
Hi, Joe. We just started getting pretty steady temperature readings around 13 Celsius.
Okay, that sounds real. I guess it
Up
just
jumping
needs
up to
fall
25.
up and get bumped.
Yeah, just needed to get a little nudge. Got everything back in position.
Did that on purpose.
Yep, up to 50.
Nice, great.
All right, I think they're still repositioning the arm a little bit.
Okay.
Oh, I just lost temperature. Dan? Yes, voltage is still good. All right, Jill, nothing was changed. Okay, we're in the flow. I do not have temperatures. I think it went back to not working, unfortunately.
Okay.
But I do have battery voltage
All right. Let's
of
see
13.1
if-
volts.
Okay, good. So we should be able to sample, but let's see if he can kind of get steady. Looks like he's still intentionally moving, hopefully. At least we have this great view. All right, that's looking good.
Oh, okay. Oh, I'm getting temperatures. I have 300. I just had 300. Well, actually, no, I don't think these are correct. But I am reading temperatures. They're being recorded in the file.
That's great.
137, 200, 227, 240, 250, 260, 260, 267, 275. Yes, I'm firing. All right, we're sampling. We're at 270.
Great.
All right, and milliamps look good. Sampling is going around 275.
All right.
260. 260. 255. 260. All right, it's now filling. The motor has stopped moving. We're still at 260. 255. 250. 260. 260. We're still filling. The motor shouldn't be moving yet. 260. 252. 270. 275. 260. The motor shouldn't be moving yet. 265. 260. 266. 270. 260. Okay, we're about 3/4 of the way through, but I still have 0 milliamps. Waiting for this to start moving. Oh, closing. It should be moving now. Can you see footage of the motor moving? All right, they can see the motor moving. We're still at 250. $230, $245, $240, $250, $230, $250. Okay, motor finished moving. And I think the sample was completed.
Did it hit 700?
I did not see it hit 700. I'll abort it and close it.
Yeah, do a close and abort.
All right, yep. I just got 785 milliamps. So I'm aborting again.
Thanks, Keldon.
All right, well,
Tell
glad
them
it worked when we needed it the most.
Yeah, tell them to stow the IGT. Thank you.
Okay, hand you back to Dan.
What did you get from Max? 280. Oh yeah.
Hi, Dan.
What
we
a
can
pain in
stow
the
the
butt.
IGT.
Yeah. Well, we're right in the middle of a watch change, so they're talking about stuff and getting set up.
Can we at least take it out
Yeah,
of the fluid?
Yeah. Can you take it out of the fluid, Kel? Can you take the bottle out of the fluid? Okay. So hold on a
So it's
second.
in a cooler spot, please. Thank you.
Yeah. He's working on it. Yeah, we want the bottle out of the fluid as soon as possible. Thank you. Sorry, it's chaos in here right now. Just hang on. It's like.
Weren't they in the middle of a sample? Can you like
What's that?
wait 30 minutes?
No, they're doing it. They're doing it. It's just,
There we go.
okay.
Thank you.
All right, there we go. Okay. Yeah, but putting this bottle away is not going to be no trick either, because we're going to have to come out, retract the basket, and then maybe we have a fighting chance of getting it in. Okay. Anyway, thanks, Akel. Great job. Sorry. Go have a beer.
Dan, do you think it would be easier to sort of fly away and set down somewhere less complex and then stow the bottle?
Yeah, we're going to do something like that. I'm going to talk to Mario in a minute as soon as he's done crossing over with Akel.
Okay.
Okay. All right. It goes back in there, but good luck, because every time we tried to do it, we got involved with the Lily thing because of the Tom Thumb, and everything was in the way. So, and no problem. Okay, I'll tell Akel you said that. But you may want to retract the basket. It might make it a hell of a lot easier. I don't know. It's going to screw up your setup, but just to keep in mind, though, we're going to want to come back to this vent and take the last major. Well, if you could stow the bottle right now, we just pick up the major and take the last bottle. Yes. So, but it all depends on what you can do, because when we tried to get it out, it was a total pain in the butt. We couldn't do it. We kept on hitting the Tom Thumb on the top of the Lily bottle plunger. So see what's possible. Work your magic, Mario. Okay, so the sampling, you got it? Okay, yeah. Not sure exactly how that dropped out of the sky on us, but hi, Tito. Good evening. So we made a change in the plan. We skipped Q and came up to M, and because we wanted to see if we could get a good temperature, which we did. So that's why we decided to do this first. Yeah, right. I mean, I don't know if you think you can slip it in, at least get it in partially, and then use the other manip. Right. I mean, if you could just sort of stand it up there and then use the other manip to get it the rest of the way down. Yes, and not worry about it for now. Yeah, because if we could keep this set up and get the other major, then we could, before we do the imaging, we could just go off and sit on the basalt somewhere where. Almost there. It's a little more elbow out. You could have made those things a little wider. Look at that. Mario, demand.
Nice job, Mario. Awesome.
Jill says, nice job. All right. So I want that other major. Not right now. Yeah. So major sampler. It's the one in the port corner here. Yeah, that's the last water bottle we got. Yep. When we picked it up off the elevator, we didn't bungee it. Living dangerously. And we did have to kick around the ice, just so you know, Tito, we did have to kick around the ICL. So I don't know if the shaft is done in again, if the shear pin, it was cocked and Akel nudged it back so we could fire both bottles. But it definitely had an issue.
Can you hand down on this one, see the proximity to the view?
Excuse me just for a sec, Troy. Thank you. Sorry. No, that's fine. That's fine. You're fine. Let's have a look at whether we need to nudge the paddles. Do you have ICL comms? Nothing yet. Oh yeah, they're not rotated in yet. Anything yet or not? He just did. Did you have temperatures? How about now? Hold on, he's restarting it. Yes, no? What? It's that window there that you want. No, no. Okay, hold on a second. Which window is it again? Well, I think we need help in getting the ICL program up. On Mario's screen. We were moving windows on Mario's screen for some reason. Yeah. No, he didn't do anything. When they started manipulating the screen to try to get the ICL program up, which they have up now, all of a sudden they started moving stuff on Mario's screen. I don't know. Okay. All right. Yeah. Not sure exactly what happened or what we did. I hope we didn't screw things up. Can you call to see if James is down there or no? I don't know. So do you have the ISO program up? Okay. And so okay. Do we go stop logging and start logging again or not? I mean, usually it's a question of quitting the program and restarting it. That's what we just did. You just did that. Okay, so we're not getting readings yet. Can we look to see? Because I think that we need to put the paddle much closer to the puck. Just from what it looks like here. That's way too far away. Can we just bump it a couple? Hold on, Gabby's in the back here. Okay. It's a little, go a little bit more. I would hold that. Well, it's touching on one face of it because it's not parallel. Do you get any readings now? How about, can you just rotate it just a tiny bit? You just. No, they're not getting anything yet. No, I mean, I would say nudge it back in a little bit. A little bit more. Tiny bit more.
Anything?
Hold on.
Stand by.
I mean, it looks from the paddle position that your alignment is good, but I think,
It seemed like it did touch down
right.
on the right side.
Right.
Is that bolt smaller?
I don't know. I would go down just a tiny bit more.
But it might fire one of the
Well,
majors.
sorry, what are you doing, Gabby? Okay. We're trying to get the ICLs working, Jill.
Okay, Dan.
Hi Dan, this is Javier.
Hi, Javier.
How are things?
We're doing okay. We're up here at MVent, and we've taken some good water samples, but with considerable difficulty. So we're just trying to take the last water sample now. Nothing?
Roger.
So it's talking but not giving temperatures.
And no garbage in the numbers underneath that, but no numbers. Okay. I mean, based on what we've been doing, I think that the paddle is still too far away. And I know it's a bit. See, it's way far away. You got plenty to go. Oh, you did? Okay, sorry. All right. All right, well, let's try to bump it out. One more. Okay, that's good. All right. You got anything? Well, I mean, it's touching on that left side of the puck. But you're not getting anything?
No, we're getting more error. Oh.
Okay, all right,
5.8.
5. Okay, just all right. So let's go in position above the orifice, please.
Okay.
And just leave it at that. And can you freeze the wrist so that we don't change that orientation? No, we got to get, yeah, okay. I mean, that's something that's been pretty valuable. It's something that Nick knows. Well, Nick knows. He told Chris, and Chris told Akel, and Akel didn't tell you. that needs to be passed along because it was pretty valuable. Well, let's go ahead and position as best we can above the orifice and see where we get. Okay, that's fine. Okay, Jill, we're gonna try to. It seems like we're pretty well set up. We're gonna try to go ahead and put the nozzles in the orifice here.
Okay, Dan, sounds good.
Okay, we're still getting temperatures?
Yes, 6.
Okay, that's fine. Yep, good. Okay, let's keep an eye on it, please. Rose, can you please zoom in and help them with that? And you might lighten it up a little bit so we can see better. That's good. Okay, 38. We're way above the orifice right now, but not so far so that we can't see where we're going. $55. $57. Zoom in a little bit, Rose. 100. We're looking for something in the 200 plus range. How about now, Charlie? 103. And when Akel was in there, he basically had that. What's the temperature? 106 is the temperature. Hold on, we're just checking something on the manip.
Yeah. Rain, yeah, I see that. It says freeze. All right. Perfect. Thank you. Peace.
Great, thanks, guys. Okay, all right. So when Akel was in that orifice, he was basically with the one nozzle right here that sort of, it just fit, and the other nozzle just fit in here, and he was just underneath the lip. It was like a glove, but you know, we'll see if these nozzles are exactly oriented the way the other ones were, but it's definitely in there with that nozzle jammed against the back wall.
So are you saying to rotate the nozzles like so?
Well, yeah, I think so from what I can see in perspective here, but I'm not positive. But you definitely have to come down, and that nozzle has to be right up against this part of the wall right here.
A little rubbing is good.
Well, you can try, sure. I mean, you know, you got the hose clamps there, which are a pain in the butt, but see what you can do. I think if you can just get down lower, and we'll see if we. I mean, you're in the flow now. You're at 100 and some. What is it, Charlie? At 30, okay. So you got to come down just a little bit more. Okay, stop. Yeah, and then it's back. You got all that space in the back there. What's the temperature? Okay. Yeah, right. So yeah, it's back there and then down. Okay, that's good. How about now? Okay. See, the way his nozzles were hose clamped, they were hose clamped more like that. And so it was fitting perfectly. just we got lucky, you know. Yeah, it was like it was more like that. Yeah, exactly. Okay. Yeah, exactly, right. But I don't know if you can get there from here. I could swing the arm in a little bit and then rotate out. Yeah, right. Yeah. Yeah. You can give it a try, but I think that's how this little hole is, how the little orifice is oriented. Yeah. Yeah, he's coming out and trying to rotate and reorient the position of the nozzles with respect to the orifice. And unfortunately, I think it's going to mean that you're not going to be able to see it that well in this picture anyway. Yeah, well, that's okay. I mean, as long as the temperatures are high, that we don't need to see it. We'll believe the temperatures. How about now, Charlie? Okay. How about now? Nothing? I mean, the bottles are venting well, so just keep it there for a second, Mario. I mean, the bottles are venting. At least that 188. Okay, just hold it there, Mario. 194. Hold it there. Yeah, I know. Yeah, that's nine. What is it? 184. So the only. Yeah. Yeah. Can you go down any more or not? Okay. You just go down just a tiny bit, and most of that is because when you're. Yeah, you can't go left anymore. So I think just try to go down a little bit more. Yeah. How about now? I would just leave it there. I mean, the only thing is when he plunges, you're going to probably go like that, right? Yeah. Okay. Right. So the question is whether you can be ready to come back into the flow a little bit. Was it now? Okay, Jill. I think we're close to being at our limit here in terms of the orifice configuration and how we can orient the sampler. So are you? Oh, what is it? Oh, it's 108 now. Shit. And there's no way that you can come back like that, huh? Sorry? Like that. Yeah, like that. Yeah, right. Okay, that's what I figured. Well, hold on. What are we getting? 108. Yeah, we're getting 108. So let's reposition a little bit. I wouldn't come up too far, like there. What is it now, Charlie? Okay. Okay. 104. Anything else? Yeah. Just hold it there for a sec. What is it now? Okay. Okay. Can you go down a little bit? Keep going. Yep. 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 Okay. Let's stop. Stop right there. Now, what is it? 177. Nothing. Oh my God, these things are frustrating. And I don't know that I'm seeing a lot of venting in the bottles right now. Okay, well, that's good. I'm glad that's it. 183. Okay, so just hold it. You see them? 185. Yeah, no, they are venting. Okay, they are venting. Okay. Jill, you ready to take this?
Yep, I'm ready when you are.
Okay, all right, Mario, just be prepared if you can to, once we plunge it, to try to keep it in position here. So just try to orient yourself as to where things are. Yeah. All right. So whenever you're ready.
So let's go ahead and
Temperatures 177. We're plunging. 186. 178. 163. They're not coming up yet. You all the way in. There's the right one coming up. The left one. Okay, well, they're coming up. So keep it. What temperature? 163. Temperature. Okay, we're 163, but the 130. Okay, 143. Can you go down a little bit? Yeah, just a tiny bit. Stop. What temperature? 154 was the last one we got. The springs are both coming up. Any other temperatures? Well, I think this one got a better sample from the point of view of it being consistently hotter, Jill, than the other bottle.
That's good, Dan. Yeah. 150 is good.
180, 180.
Good.
We just got an update. The springs are, what is it? 185, 181. Yeah, I think the springs are up, but hold on a second. Let's give it another couple of minutes.
One's still coming back
Yeah.
slightly.
Yeah, it's still moving. Okay. 190. Way to go, Mario. What do you think on the left one? I think the right one stopped. I'm looking. I'm looking. Well, I'm looking at that. Oh yeah, no, it still is coming up. I'm looking at that little mark on the paddle. Yeah. Right. So it's still coming up a little bit. So it's still 187. The left bottle is still coming up. 189. 179. Now it looks like it stopped. 183. Okay. Yeah, exactly. Right. Okay. All right. Let's take it out of there. Oh my God. All right. Now, yeah. And before we leave here, we're going to take one of those temperature loggers and try to jam it in there, just for the sheer hell of it.
Thanks, Dan.
Okay.
Thanks,
Yeah,
Mario.
Jill. Okay. Jill says thank you very much. Okie dokie. And the temperature loggers are in the bio box on the starboard side. There's 2 left in there. The other thing that we're going to want to do is, and I don't know, is Tim online or not? He's not online.
I don't see him. No.
Okay, all right, that's fine. Is Thibaut online, or is Thibaut not here either? No.
Thibaut's not here either.
Oh,
Ross
the elevator's
is there.
on board. Okay.
I'm here. I can help.
Well, hi, Ross. No, I'm just
not
trying to
sure I
get
can.
some. I'm just trying to get some sense of the low T array that we might put here. I mean, there's some down at the base, but I'm just wondering, whether we want to put something here in the diffuse flow up on top, in addition to the high T logger that's measuring in the orifice. We certainly could try to do that. I don't know if we'll find it again or if it'll be burned to a crisp by the time we get back. I have no idea. But anyway.
Dan, I just saw that we received an email from Stefan at 9. He thinks this is not where he structure, but actually is flea vent, or the vent he called flea. He says to check the top of the old M vent structure for low T venting. So he says it's just a few meters away. I'm not sure which direction.
I don't.
Maybe
Yeah.
we can look around a little before we leave the site.
Right, but okay, let's table that discussion for the moment, because I know that Stefan feels strongly about some of what he recollects as positions. I do too, and I'm pretty confident that this is the old M-vent structure here. But we'll have a look around before we leave. But irrespective of that, and frankly, it doesn't matter, because this is all M-vent. They're all active chimneys within 5-10 meters of where M-vent was, and so I don't really care about flea vent, to be honest with you. I'm a little,
I don't care about the name. I guess
yeah.
what I took from that is maybe there is a lower temperature fluid nearby.
There certainly may be. There's
right,
but there's a whole ridge of venting, which is what I'm sort of interested in trying to survey and document. And so, because previous cruises haven't done such a great job of really characterizing that, and also because it has changed, because M-vent didn't necessarily have the same configuration back, whatever, 10 or 20 years ago. So how it's changed and altered since the last eruption, I think, is quite interesting. So anyway, I think we will look around, so that's fine. That's a fair statement. We will do that in a minute. But what I was trying to get at was to figure out whether we should leave one of the low T arrays here on the top of this one, seeing as how we're going to try to instrument it with a high T logger.
Okay. Maybe
So
over
my
to the
my
right
general
where the white chimneys are.
Yeah, my inclination is to try to do that. So I'll try to sort this out now here in a second. So Mario, whenever you're Yeah, so hang on a second. Let me ask you a question. We in the starboard swing arm, we've got these low temperature arrays that we made from Tim's loggers. So the little stubby things. I would like to put one on the top here in the diffuse flow on the top, and I think it'd be better to do it now before we install the high T logger, because once we install the high T logger, I want to move away and not bother it, right? Yeah.
Okay.
Okay. So is there room to get the right swing arm out?
Yeah, it looks like we have some pretty good clearance.
Okay. So if we could do that,
Let's go ahead and start the swing arm out.
and there's 4 of them left.
And then,
They're labeled 4 through 7.
like, don't let it slam. Just kind of like.
Okay, we're not recording anything right now, right? Okay, no, that's fine.
Pull this back. Go ahead. Oh, really?
Okay, you can pick up that one that's hanging up there with a red loop on it. Yep. And just let us see the number so we know which one we've left here. Yep, okay, that sounds good. Take a picture, take a snap of that, please. What's that? Yes, please. Yeah, Rose, can you pan up, please? Okay. Now, as far as where to place it, I guess I'd like to place it. I guess I'm wondering how far over to the right you can get without having to move too much.
Like in the white part?
Yeah, in the white part down there, yeah.
And any particular side down?
No, it's going to lay however it's going to lay. The sensing tips are these little nubs that are on the end of the loggers right here. But let's just see how it's going to lay, because it's a lot of vertical surface here. So if you can try to nestle it into some place that's a little more horizontal. I don't know. We don't have a very good view of it, but how is that sitting right there next to that guy? Yeah. Okay. Okay. All right. That sounds good. Yep. Let's see if it stays. And it does. Very good. Okay, let's just we'd like to take a picture of that, but we may have to do it after we install the logger, because I think right now we're in a good spot to try to get the logger in there.
I believe you can get a grab of the brow cam.
What's that?
You can get a grab of the brow cam.
Yeah, well, we can do that. We can do that later. Okay, so at this point, Mario, let's open let's stow that guy, and we'll open the bio box on the basket and pull the logger out. And I think the only challenge here is going to be giving yourself enough space so that you can actually get it in and not have it interfere with all the crap on the front of the basket. You're on the lights on a stick. There you go. Okay. All right. So I guess the question is, do you think you can do it in this setup, or you think you have to change the setup in terms of jamming it in?
Can we have the syntactic foam pointing off to the starboard side of the vehicle instead of pointing toward us?
Well, I think we can for now, but it could be that then you're going to have to in mid-water take it and give it a gentle nudge to rotate it out. You see what I'm saying? In other words, if you yeah, because if it's over here and a vent chimney grows, it's going to fry it. In other words, it's always better to have them hanging out in mid-water. That's the idea, right? So the idea would be optimally, if it's venting here, to have it be like that, right? Like that. So that's why I'm saying I don't know whether it's feasible. I mean, I think you have a good setup here to insert it, and then the question is you insert it, and then you maybe come back and we'll try to nudge it back around like that. I don't know. It's just a wild ass idea, but because you have a good setup now, and I yeah, I think maybe he changed his orientation. When he was more like this, it was right behind us. You don't see it now because you're a little at a different angle, right?
Yeah, and yeah, the butt cam's off to the port side of the vehicle. You know, if it's super close, it could be off stars.
Right. Tito, did you confirm with the bridge that we are in fact going to come up and recover it at midnight? Can you do that just to make sure they know? I'd left myself some wiggle room, but let's go ahead and make the call. Yeah, right. Yeah, it's always easier to get it closer to the bend. Thank you. Yeah, you can go even further up to the. Yeah, go. Yeah, just let it slide down. Good, perfect, right there. Great. That's a good grab. Okay, and if we could close that box. So this is 2020-009 is the logger we're going to install here. All right. Now your next challenge, should you choose to accept it.
Do you feel comfortable like placing it and then mid-water kind of just tap it and see if it rotates?
We can try that. Yeah. I have done it before. Not on chimneys this tall. I think it's going to depend a little bit on whether you can plant it and feel like you can go, pretty deep with it. If you can, then that means that it's, got a chance of just, being able to rotate pretty easily. But that's the challenge. Zoe, can you zoom out? Or Zoe, sorry, Rose, can you zoom out, please, so that you can see more of what's going on? Can you do a 4K? Thank you. Okay, can you zoom in now, Rose, and so that you can see about getting it in? That's good. Javier, is that your mic? There's somebody's mic. If you could mute yourself, please. Oh, it's Ross. Oh, sorry. Okay. Oh, that's right. I should have recognized his girls. All right. Now the question is can you jam that puppy in there? Yep, that's it. Okay, now keep going. Yeah, keep going and wiggling. Go any more? Yeah, that's okay. Just keep trying to jam it in. Keep trying to jam it in. It's titanium. It can take a beating. Yeah. A little bit more. Yeah, now we're talking. Okay, Mario, keep going. A little bit more. Okay, easy does it. Easy does it. Okay, now down a little bit. Yeah, down more. That's it. Okay. All right, now, if you can, gently let go. And yeah, right. Yeah. Can I guess, can you, yeah, can you just open the claw a little bit before you do anything else? And see what happens. That's it. That's good. That's fine. Okay, now if you can just, before you come all the way up, Rose, zoom out, please. Okay, now if you can with the claw, just move up the tube and see if you can rotate that this way a little bit by well, keep going up, go down and up. You're going to do that by rotating the wrist. Okay, let's try there if you're around. Yeah, and I wouldn't grip it. I would just take it right like that and just try to rotate a little bit and see if it stays. It may not. Yeah, there you go. That's what I'm talking about. Tiny bit more. Okay. All right, let's try to, yeah, like that. Good. You taking a snap, please? Let's try to get the arm off of it, and let's try to back off the chimney for a second, but not move very far away because I want to take a picture of this. So if you just back up slightly. Okay, this is 2020-009 logger deployed. You guys got it? This is deployed. I hope. You stopped the 4K? Okay, well, you're going to start it again in a minute, but once he moves off and retracts the basket. Looks like you got that guy behind you.
Oh, wow, that is close.
What is that?
That is the chimney behind us, roughly. Zoom out on brow and center up.
Yeah, it'd be great to get rid of the basket a little bit to bring it in, so that we could try to get a better picture of the setup.
Hold there. Down, pull back.
The major sampler, is it okay? Yeah, it is. Okay, good. That's fine. That's perfect. That looks great, Mario. You're still away from that chimney. Can you keep coming in on the porch so that we could take pictures before you leave?
Go ahead and bring it in.
If you could just hold this. Okay. Now maybe let's get out of here and maybe we'll take pictures from a different orientation so that you're not complicated with this thing back, okay? You're still recording 4K? Okay.
With the Afghan tilt?
Did you take a snap of that? It's okay. We need, yeah, we need to do something about getting maybe a little bit further away so we can zoom in on it without the bottles all in the way. Okay, good. Yeah, that's Nicole's experiment down there.
Go back to the other guy. Reposition this guy a little bit more to the left, a little bit more down, right down.
That would be great. Yeah. Take a grab of that. You still in 4K? Yeah, you do. Okay, good. Okay, so that's the image here of this southern, well, one of the southern M vent chimneys with the low T loggers there in the diffuse flow and the high T logger in the orifice. Pan out, please, and left, please. Okay, that's good. Now, Mario, here's what I'd like to do. I'd like to try to take some imagery of the vent structures that are aligned here. From here, going to the northwest. So let's sort of move off here to the left.
Okay, so go to the left.
Right. So right now you're headed west, right? Yeah. Exactly. Right. So yeah, I mean that's the trend of the structures. So ultimately you're going to want to come and sort of face to the northeast to image the west side of them, right? And we're going to try to lateral along it. So
Okay.
all right. So I'd like you to just come around and face this heading northeast right now. So back up from it a little bit and then come around and then let's line up. I'd also like my camera, which seems right now to be mostly pointing down, to try to get it down and forward. Could you tell me who just came into the room or who else is in here? Sorry. That's.
Need a backup first, right?
Oh, okay. Oh, I see what you're saying. Right. Okay. All right. Let's get yourself out of here. I was asking who else just came into the room. Okay. Tim, are you in the room?
Hi, Dan. Yes, I am.
Okay. Well, we deployed one of the low T arrays at Tica, right by the chimney that we instrumented, and we just are here on one of the structures at M, and we've instrumented it with a high T logger and one of the low T arrays placed in the diffuse flow near where the chimney's venting.
Yeah, thank you. That was great. I was able to observe the Tica deployment during another meeting, but I missed the invent deployment. So.
Okay, hold on, Tim. Hold on. Sorry, say again.
Facing northwest, and you said you want a lateral to the right to catch all these
Right,
chimneys.
right. So what I'm trying to do here is get a good sense of, because there's a whole sort of lineament of structures, right? Okay. So right now we're pointed, yeah, pretty much parallel to the trough axis, right? Because the trough axis is going 350 for the most part. So so that's a little bit more to your right. So if you right now flew from here and just headed northwest, can we do that slowly and fly over them with a down camera on?
So our position right now, just go straight?
Yeah, well, I would come right a little bit, come to 345 or so, and see where that gets us. And turn the down camera on. Okay, so this structure here, this big structure, right? So this is the one that is the old M-bend structure. Now, let's just stop there for a second. Now, can we go to that one? And there's the arms plate that you can see there in the distance. You in 4K, Charlie? Yes. Yes? Okay, good. So just stop the clip and then start a new one. Okay. So let's go to that structure right there and just rise up it for a minute.
Okay. You want me to slowly go?
No, I just want you to go straight to it and right. So right, because right now you're parallel to the trough wall, right? And the whole trend of these vents that are part of this M vent complex. So I just want to go take a look at that one. The one that we just sorry, go ahead. Sorry.
And we're good with the temperature logger being in that's its final position. Are you happy with that?
Yes, it is where it is. That's what we sampled the fluid from, so that's where we want the logger to be. Oh, I think for now it's okay. Well, let's just leave it for now.
It does look like the foam part is a little extended out.
Yeah, right. So, okay, so let's just go to this guy, because I think this is the old M vent structure, and the other one is a slightly different one. That's just a little bit to the southwest of it. Okay, but let's go over it with the down looking camera on. For now, yes. Okay. So I'd like you to just go straight towards it, and then climb up and over it, keeping it just directly below us. Sorry, say again. Oh, great, thank you. Okay, so there's Nicole's arms panel down at the base of the structure. That's the 2005-2006 flow surface. This is the old M vent structure here. And it has some staining on the top of it. Rose, can you please, once we get closer, can you zoom in on the top to see if you see any shimmering water there? Okay, so now you're going, right now you're heading 020, which is okay. Keep going. I'm just trying to orient. Yeah, no, you're doing fine. I'm providing orientation to the people who are listening, and for myself to just have me oriented as to what I'm seeing. So there's a little bit of a bacterial mat on the top. You can try to focus on that and see if it looks like it's shimmering. Yeah. Okay, just try right there. Just try to focus right there. Okay, go down. That's good. Go down. The other down. Keep going. Keep going down. Keep going down. Keep going down. Yeah, it doesn't look like there's any. I mean, there's bacterial mat there. There must be some fluid flow, but it doesn't look terribly hot. Okay, zoom out, please. What's that? Yeah, but it could be moving because of the thruster motion. It's a little hard to say whether there's, I mean, it could be that there's a little bit of fluid flow. I wouldn't be surprised because it's got a pretty good coating. So we're flying 020 to get to this structure. So keep going up and over it. And if you want, you can come up and over and a little bit to the right of it. That way we'd be sure to get Nicole's experiment in there too. So that looks good. So keep coming.
Good speed.
You can go a little bit faster if you want. Yeah, just as long as you rise above it. The last thing we need to do is to knock it down. Yes, right. Yeah, you can get a little bit higher and keep going. And then once we're clear of it, let's go ahead and drop down. So keep going. Yeah. Yeah, that's very good. Yeah, that's great. We're looking at the down looking pictures here. And we've got great overlap as we're going up and over it. Just keep flying on this heading. We're heading 020, a series of pictures. Yeah, you should note this in the down-looking camera transect thing in the imagery, okay? Like that we're doing a survey here, heading on 020. 4K can be off. Yeah, thank you. Thanks for reminding me. So let's just go a tiny bit more, Mario, so we get the sort of complete structure and the wall. Thanks for pulling that up, Gabby. That's great. Okay, now I'd like you to go north, please, and come down to about 6 meters. It's behind you. You mean the one we just went over?
Yeah.
Okay.
Yeah, your camera's over it, but Jason's long.
What's that? Well, my camera is in the back. The camera is way past it now.
Your down cam is right around the file boxes, right? They're on the swing arms.
No, the camera is right in. Well, it's in the middle of the vehicle. Yeah.
Oh, okay.
Yeah. Well, in the back of the basket, but. Okay, but you're out over the AST wall now based on the altimetry. So let's just stop here and go down.
Hey, Dan, this is Tim.
Yeah, go ahead.
Yeah, can you just describe the number of structures that are here, just so I know? I mean, I'm familiar. I see the old M vent, and I remember seeing one north of there, and then maybe another smaller one. Just trying to get a.
There's probably, I would say, at least half a dozen, if not 9 structures. Some of which are more active and some are less active along a lineament that's trending parallel to the sort of 350 trend of the axial trough wall here. And that's one of the things that I'm trying to get a handle on, is to be able to basically look at the sort of array of structures along that lineament. So and there's enough topography that makes it pretty complicated to do. Okay, so you're now back heading west. So, but you stayed in the same place, right? Okay, that's fine. Okay. Okay, so now you're down at about 6 meters altitude. Tim, you have to stop for a second. I can't do two things at once, so I got to pay attention to what I'm doing. So I'm sorry, just hang on. Okay. All right, so here we've got a bunch of pillars. I need to see something better in here. Okay, so you're pointed more north. That's the butt cam that I'm looking at right there, right? I mean, what's that? Oh, it's looking off to starboard. Okay, okay. Yeah, okay. All right, so so those structures that are right there, can you put those in the field of view? That would mean you'd be turning to right some more. Rose, can you do something with there's something wrong with the settings on the camera because it shouldn't be that way. I know we're up higher, so that's part of the problem, but. Okay. All right, well, we need to get down so I can figure out better. Yeah, no, I know, but I'm just trying to figure out where. Okay, so right now you're facing towards the axial trough wall right now.
Yes.
Okay, so let's stop spinning. All right. And all right, I mean, it seemed to me that we were going on 020 and that we should have been up in here. So right now we're here, right?
You see all these track marks?
Yeah, that's us.
All our past positions for the past couple minutes.
Yeah, right, right.
So we've just been doing spins and going up and down.
Right. Okay. So
you would
it's
like that to head north again?
yeah. So I think at this point, yes, I would like to head north. So or actually 350.
350, Roger.
Oh, okay. Let's stop there and let's go forward now. I think, well, we're at 9. Yes, I would like to come down to about 6. Okay, so let's just keep going in that direction. Okay, can we slide a little bit more to the west? I don't want to turn west. I'd like to just, can we just lateral west a little bit? Or you have, maybe you need to turn because the terrain's pretty hairy. So.
The donut a little bit.
Yeah, that's pretty good. I'm at a certain point. I need to try to find the lineament of vents again. The lineament, the sort of the linear chain of the vents again. Which I think are more over here.
Okay, so you want to go west?
I think we want to go west a little bit more.
Be a little patient, yeah. Go ahead and sign up on our leash a little bit. Help our donut out. A little bit, but we'll stay outside that center of that donut.
You still have the boat going west a little bit, Tito? Okay. I don't know. I have to find where we were before, which I think is right over here. So it looks like another 10 meters or so. I mean, from where you are here, can you just do a slow spin just to try to see if what we can see both on a side scan and visually? Okay, so that's them right there. So just stop right there for a second. So that's what? That's back to the southwest, which would mean that they're right there, that we're looking at them right there. Okay, can we just go up a little closer to them? Is that okay in terms of the nav?
The donut.
Yeah.
It's out of there.
And can we try to get down lower? I'm trying to figure out if those were the two that we were just at, which sort of looks like, because we're right back in that wuzzle, right?
Exactly where we were.
Okay, so what I'd like to try to do is get down to those levels and then have the vehicle just swivel and look up in that direction in the northwest direction.
You want to go to that and then face northwest?
Yes. Because once we get down to that level, then we should be able to see the other ones in the distance in front of us. And ideally what I'd like to do is to have you then fly, once we can get a bead on them, is to fly directly over them.
Okay. So what we did in the opposite direction?
Yeah. Yeah, because what we just did was fly over those two.
See that kind of bridge. And I see your Subway sandwich right there.
Right, the big platter.
The arm?
Yeah.
All right, so I'm gonna line up on this vent right here, facing northwest. We'll fly over it.
Yeah, but it's the ones in the distance that I feel like we need to get a handle on so that we can. I can't hear you. Say again. Little tough to say.
Yeah, I see your temperature logger right there.
That's
we
right.
Saw the arm.
Right. So right now, can you just hold your heading here for a second?
Hold it.
Okay. So can you take the port manip and use it to sort of line things up, because it's got a pretty good field of view, and point it sort of a bit out and forward. There you go, like that. Okay. So right now it's more or less aligned with where we're heading, and we're heading 345 right now. So you've 317. Okay, so 317. So well, that's the one that we just that's the one that has been instrumented, right?
Yeah, we got
right.
the temperature logger over there. The one
Right there. Right.
Yeah.
Okay, and so this line, right? So this in a 315 direction, we're lined up on this smoker, which is southwest, the southeasternmost, sorry, and then we're looking up to the northwest there, to the one where the logger is.
Yeah, but the arm is lined up pretty good. But
Right.
The arm's facing a little to the right of the vehicle. So
Yeah.
it'd be probably more like 330.
That is where the camera is pointing. Is what this lineament is.
Yeah.
Yeah.
The arm is
Right.
probably 330.
Okay. All right. So from where you are now, can you fly from this one over to that one and over that one?
Yes.
Okay.
And you want to use the arm camera?
Just leave the arm camera the way it is. You can maybe point it down a tad, but I think it's going to help guide us. That's probably too much. No, sorry. I like the view up a little bit more. Up a little bit more. That's good. Stop. Okay, let's leave it like that. Okay, so if you can just go fly now from this one to the other one. So Tim, I'm sorry to cut you off, but it's a complex enough area that I'm trying to figure out how to best sort of do an imaging survey that would allow us to really place these well. So I've got the down looking camera on, and I'm trying to fly over the series of vents from vent to vent so that we can then sort of spatially relate them, because we've got good nav and the bottom images have lots of overlap. So that's what I'm trying to do right now. But then what I haven't done yet is north of these, there is the other lineament that continues up to the northwest, which is where the initial sampling that we did here at M and the other logger is placed. So if you want to ask the question that you were going to ask me quickly, Go ahead, go for it.
No, Dan, you're doing exactly what I want to do. What it's fantastic. You know, to be able to enumerate all the structures that are there and their orientation all the way up to the, you know, of course, the biovent. Frankly, it's a great idea. I'm really glad you're doing that. Especially documenting that with the downlooking camera is fantastic.
Yeah. Okay. All right.
You know, several structures at invent. Good.
Okay. All right, Tim. Got it. Your voice is lagging a bit, so I don't know if it's our bandwidth that's struggling or what. But okay. So I'm going to get back to helping Mario sort of drive because I'm driving him a little crazy here with all these maneuvers. Okay. So as far as I'm concerned, we're lined up. Fly from this one over to the other one, and you can fly, you know, a little faster than what you were doing. That's okay. We got tons of overlap in these images. And what I'm trying to do is after we get over this one is to try to see the next ones that I'm almost positive are in the distance on the same linear, maybe a little bit.
Like that way?
Well, yes, right. No, right. But this is the front. And I think the other ones are maybe, let's scotch off to the left, right? So it may not be exactly the same lineament, but it's generally trending parallel to the wall, and the wall trends 350. I know that for sure.
So do you want to? We're heading 318.
I know, but I'm trying to orient this one to that one first, and then I'll deal with the rest because see that trend right there is 350.
So we'll maintain
Yeah.
318.
Yeah.
So we'll go in this direction.
Yeah.
As soon as we clear this vent that's right underneath us,
Yeah.
underneath us, we'll start heading down, try to get a better view of things.
Right, and then you're gonna have to fly over the next one too. Remember.
To our right.
Well, yeah.
While maintaining this head.
Yeah. So is it okay that we're flying into the donut or not?
I'm going backwards actually, trying to reposition ourselves over this vent so I can see the other one.
Oh.
I thought we were gonna head to 318, but you wanted to keep the other one in view. So now we need to get it back in view, and then we'll go ahead.
Okay. Right. So I've got, it's just coming into view in front of you, right? Yes, off to the right. With this one just below us.
Now maintain 318.
Okay.
We're gonna lateral to the right to keep it in view.
Okay.
Cameras over that spire.
Right, and I'm just seeing the other one in front of you.
See that guy?
And that's the one that the logger is in.
Yes.
What's that? That's what I'm trying to do eventually, yes. But I'm trying to get myself oriented to these structures. So I'm doing the best I. Yeah, no, I understand. Part of it is it's complex topography, and even though I've been here a bunch, I'm seeing it for the first time in this perspective. So that's what I'm trying to do, is be able to collect the data so that I really know what's going on, at least on this dive series. And it'll help us assess how it changes over time. Okay.
Use your
So,
downward camera to stay along this ridge.
okay.
Up,
So,
and then we're gonna go over the vent with your temperature logger.
okay.
You see your temperature logger in the down cam?
Barely, yes, right there. Exactly. Right. Yep. Now, so that's the M vent. That's the M vent one. Exactly. That's the one that we initially fluid sampled. That's right. Exactly.
Currently over facing 318.
Yeah.
Got that. You see on sonar.
Yeah.
See that's the target.
Right. Right. And we're just a little bit west of them.
Ever so slightly.
Right.
Southwest. Of them.
That's right.
And then, until that's
Yeah.
facing our starboard.
Yeah, right.
Starboard quarter.
Right. So let's I guess you're still going forward, right?
No, I have
Oh,
stopped.
you stopped right here. Okay.
So I can grab the bearings.
Right. Okay. So at this point, if we turned to the right, to the northeast, we would face that guy and came down, right? It's below us.
We'd probably almost pivot on that camera so it would stay relatively underneath us.
Right. Okay. Because I guess what I would like to do, if we could, is now take a view of it this way, not down, but that way.
Horizontally.
Horizontally.
How we were originally set up on.
Yes.
Okay.
You're not seeing much in the video because we're basically flying this using the down looking camera and the overlap that we're seeing in the down looking camera. So I'd like to be able to get in the Sulis camera that view looking to the northeast of the instrumented chimney. There you go. With the marker right by it. Yeah, well, you got it right. That's right. Or well, east, whatever.
All right, you want to face east?
This is fine. This view is fine if we can just get down to its level. Okay, so what you're starting to see in the field of view right now is the vent that we first sampled when we did it on dive 13.0. No, it wasn't 1306. There 1306 was P and Bio 9, and it was 1308, I think. But that's the M vent chimney that was fluid sampled for the first time. So yeah, you can just get down a little bit lower on it. Okay. So there you go. So that's the M vent chimneys. Rose, can you please check the ISO, right? And now zoom in on where the logger is going into the vent, please. Let's have a look at that, because it looks to me like there's a beehive that may have grown over it already. Can you, yeah, zoom in and focus, please? Yeah, if it's out of focus, zoom in quickly, then focus, and then zoom out. There you go. Okay, so just hang on, be patient with us. Okay, that's, no. That looks pretty good right there. Stop. Okay, now zoom out. Okay, so there's the P-vent logger, right? Stop now, stop now, stop. Okay, take a grab. You're doing 4K. So there is the M vent, sorry, the M vent logger, and it's got a beehive that's grown over it. I don't know, probably a foot or so, something like that. Since we deployed it, whatever, maybe a week or a week and a half ago. And that's the yellow marker that we put down on that dive. Okay, zoom all the way out to get the full structure. And frame it up in the whole camera view. There you go. Okay, so that is the instrumented vent, and we are now just up a little bit to the northwest of where we were before, right? Because those other vents that we went over are behind us, right? But no, not behind us, but I'm saying we're facing east. Those vents are off that way to the south, right?
Yeah, so I guess it'd be to our right.
To the right, yes, exactly, right. Okay, so what I'm wondering about is from right here, what happens if, first of all, can you pan up on the port cam and try to get a better view of that? Okay, so that's good right there. Okay, so there you see the instrumented M vent. Now, what happens if you just pan that camera slowly to the right? Okay, so the other chimney, see, this is what I was trying to get at. The other chimney in the up at the top level, right, my thing isn't working, right there, right? So can you pan up just a little bit? See, that's one of the other structures up there. And there's this whole ridge right in here. I know it's in the distance, but okay. Okay, so come down a little bit. On the arm, sorry, yeah. And over to the left a little bit. Okay. All right. Okay, that's good. Okay, so now, what about if we lateral along? So this feature in the sonar in the blue view, right, that we're seeing, that bright reflector, is this thing in here for the most part.
That's saying that's 12 meters away, whatever that bright target is.
Right.
This is a little closer.
A little closer. There's something else. There's something else behind it.
See if there's, we can see 12 meters out.
I mean, unless that's I mean, that may be the AST wall. Yeah, exactly. Right.
Yeah.
Maybe the wall behind us. Okay. All right. Okay. So what I'd like to do is from here, and I think it's probably not a good idea to just lateral because I don't think you can see well enough. So I think, can you just sort of go to the right?
45 degrees, a lateral and a forward.
Yeah, so something like that, just so you have a somewhat of a view of what's going on. And if you want, you can point my camera a little bit to that way too, so you can so we can see a little bit more, a little bit. Just so I'm just trying to see so that you can use it as a guide to as obstacle avoidance. So there you go. So that's, yeah, okay, that's good. I'm just trying to establish what is going on with this ridge here and where that leads. So we're now turning to the right. We're turning to pretty much head a little bit more south of east and along this ridge. Okay, go ahead. So it's that view in my arm camera that I'm seeing, that's the lineament that I'm trying to establish, because that leads to the next vent up there. Right, so we flew down this side of it. We flew down that right side of it, right? When we just, on that traverse that you just made. Yeah, exactly. We're just taking a spin out of the cable right now, which is why we're up off the bottom a bit. Are there any questions in the chat? I don't know, I haven't been paying attention. Good, okay. Yep, okay. I can see the logger and the vent chimney right at the bottom of my camera. Nuno Javier, I don't know if you're back online here.
Hey Dan. Yes, I just logged in a few minutes ago. Can you summarize a little bit what we're doing right now? I'm a little bit out of context. I just went very quickly through the past on the YouTube feed. We can go back in time. And I see that we're not doing 3D mapping, but can you just summarize what we're doing right now?
Yeah, I'm basically doing down-looking imaging to try to establish the relationship between the vent structures, and I'm using the down-looking imaging to help do that. The area is complex enough so that I was trying to get a better handle on where the vents were with the relationship to each other, and document that with the photographs. So so that's what we've been doing right now. What I will do is at this point, Mario is going to take us from, this is the first instrumented M vent structure that we were working at. It's small-ish, and I was going to go up to the older M vent structure, which is to the southeast of this. So that's what I was, in the process of doing. So, and Mario is going to now go ahead and drive laterally to the southeast while he's, moving the vehicle along this ridge that has the venting that's going on. So you see the big structure in the background here. That's one of the older M vent structures. We did spend some time sampling on one of them. So we did the water sampling here. We didn't actually do anything at Q vent.
Okay, I understand. Which cameras are you using right now? Are you using the arm
Well,
camera or just the down looking from the bottom
we're,
of
we're,
Jason?
we're using all of them to try to orient ourselves, but we're using the Sulis camera, which you see the view of right here, and the down looking camera as well.
Okay, thanks.
So Mario, this structure right here, can we sort of slowly rise up above it and go up and over it? No more lateral. I'd like to look at this one for now. Yeah. And can you point, can you point the arm camera a little bit so that it's further left and out of our field of view? Sorry. Yep, like that, something like that, and up a little bit. Yeah, good. That's good. Right. Okay, so there's another one of the M-vent structures. Lots of diffuse flow up on the top. You think we can capture this in the down-looking camera if you fly over it? Is that doable from this, from your? Okay. Yes. Is it still on or not on? Yeah, let's put it on, please, right now. And our course right now is 116, sorry, 116. And just keep heading for whatever that is right there. No, you can just go straight for it, right? Is that okay? No, that's okay. Don't worry about my arm camera. That's all right. Just you head straight forward. That's the arm. That okay. Okay, so that's one of the panels that we put down on the dive a day before yesterday. And it's right on the upper wall of the axial trough. We can go ahead and fly right over that. Yeah, yeah, it's going, I think, yeah. Yeah, and then you see some of the white staining. That's on the, that's to the, we're heading heading southeast. So that's on the inner wall of the trough here. And these structures that we're going to come to right now, all of this bright stuff that's right here. Okay, I think that's probably got it. This is like a big lava pillar right here. More venting along the top of the wall right here. Could you change the scale on that, Tito? Down to 50? Okay. So here are these other structures. And I'm going to fly right over the other logger that we just put in. And it's this wall too that I was trying to figure out. That's where I got myself mixed up. So we're flying right over the logger that we just put in, and the TAMs, Tim, that you see right down in the bottom of the center bottom of the screen, that's where we put it, the TAM, the your low T array. So let's fly over that so we get that in the field of view here, Mario. Wait, hold on, sorry, just hang on. That's great, Mario. Okay, that's great. All right, so good. Okay, so if you don't mind, if you could just stay here and then turn back and face that structure, that vent structure that we just went over. Just turn yourself around and face it. Yeah, that was the 315, right? More or less. Okay, what? Sorry. Yeah, okay. Hey, Ross. So, all right. So what I tried to do was use the bottom camera to try to accurately fly along the lineament that I feel like we've been instrumenting. So we now have 2 loggers at 2 of the vents along that lineament. Nicole has her experiment down here, and it's sort of a hydrothermal lineament, for lack of a better descriptor, here along the east wall. That's pretty complex because it's also complicated with a lot of collapse and pillars and ramparts and whatnot. But this is where the venting is now located, and it's pretty distinct in terms of how much more venting there is than what there was certainly a couple of years ago. So that's what I was trying to establish with the bottom looking images, which I thought were the best way to do it. We can take this structure here. I've got, it's 9:45 and I got about a half an hour. So, because I think Tito, you said 10:15 you want to leave the bottom? Okay, so I got about a half an hour. We could try to do some imaging of one of these structures and sort of do the best we can here on this dive. So what's the consensus?
I was just hoping we could choose one of these if it's feasible from a navigation point of view to try and get the 360 imaging done.
We can give it a try. We can, the one that we're sitting over right now, we could try to do that. That's the one that's in front of us. There's the Mario, the one that we're seeing. What am I looking at here? This is which camera is this?
That is the starboard facing nip cam. So it's on the port side of the vehicle,
That's
facing the starboard side.
facing the starboard side. Okay, and that's the that's looking forward, right? This one.
Yeah, this one.
Right, exactly. So that one's looking forward. So that structure that we just imaged, do you think that you could go up and down it all around or not? Yeah. Because I can't remember where that obstruction was. That remember you when we were up on the top. It was that guy. Right. 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 So right. So should we go try to do this one? You think you can, yeah, you think you can go up and down this one more or less all the way around?
Yeah, I think so.
Okay. Okay, so shall we go, can you go over to that one and sort of settle up in front of it? Okay, that one there. So you see that chimney that we have in the field of view now, everyone? So that's the one that Mary is proposing. It looks like it's pretty clear all the way around. So let's go down to the bottom of it and try to get set up to image it. That's the one that's above Nicole's experiment. Excuse me for a second, Rose. Okay, and I can't remember if you were in on any of these imaging surveys that we did, Mario, but basically we get down to the bottom and we try to line up, get the exposure right. I have to pan all the way out and we try to fill the frame in terms of being close to it. And then we do sort of a slow up and down, not too slow, but an up and down in like 30-degree rotational increments. What's that? No, I've got some, thanks, but thank you very much. Okay, Nuno, so we can try to do this one.
Yes.
And it's
okay.
in a similar way that we've done the other ones.
Okay. How tall do you think? Do you think?
I think it's about 8. I think it's about 8 to 10 meters tall.
Okay. Okay. And we have like half an hour to do it all, right?
Yeah.
Okay. If we very pressed on time, we can do
out of the way.
45-degree increments, and what is important is the 360 around them that we do. At least, well, two would be the best.
Right. Okay. So I'm trying to move the camera in such a way that I don't get any obstructions. And I don't know if I have a little bit of the starboard manipulator in the field of view. I don't know what I can do about that.
Can you rotate? Can you pan the Sulis camera to the left?
No. He's got it. He's got it out.
Great.
He's got it out. So I'm pretty much oriented in the direction of the vehicle right now. Okay. And I don't know what you think about that exposure. That seems too bright to me.
Yeah, you can reduce a little bit.
How does that look to
Perfect.
you? Okay, I think that looks pretty good to me. And you're down on the bottom, right? You can't go down anymore. Can you go down a little bit further? They're interested in getting as close to the base as possible, but it all depends on seeing what you can get, because we don't want to go on top of Nicole's experiment. So I would say, how far down do you think that is? What do we have? We have 3 meters to go. Okay. Oh, I see. Okay. Okay, that's stop. Then stop. Okay, this is as far down as we can go on this because of the experiment below us. Okay, so and right now he's just about. So we're going to start at 0 degrees.
Okay.
And do you want him to get any closer, or is this okay?
No, this is okay.
This is okay. All right. So now, Mario, can you just keep this heading and just rise straight up? Okay. And I'll tell you if you need to go faster or slower. Yeah, 4K on. Okay, so 4K on and leave it on. Okay. Okay, here we go. I think this is a pretty good speed. Yep, this looks good.
It's good.
Okay, so then you've got it noted, Charlie, in the in the logs, right? And what's our altitude now? 4.7. Yeah.
I just wanted to know, so do you plan to do a 360 if you don't have time to do all the sides to have the overall view of the structure after all?
Well, we're going to try to do the best we can here. We are going to go all the way around it. That's the plan.
Okay.
And okay, so this is far enough up, Mario. I would hold it here. Yep. And now let's go 40 degrees to the right. So meaning you change your yeah, and yeah, okay, and we're gonna keep doing that in like 40-degree increments all the way around the compass. Yeah, let's try that. 0. Whatever. Close enough. Yeah. Okay, and then just once you get to that heading, then lateral over to center it on the in the Sula screen, and then we'll go down. And we're keeping the 4K on all the time. Okay, he's coming through 320. Okay, he's almost to 308. Okay, and then he's going to center us up, and then we will make another pass down. So you guys are writing the times down when we're up or down, okay, and the start and stop of each of those vertical traverses. Okay. All right. So this is pretty good. Doesn't have to be exactly in the middle. So it's a pretty skinny chimney. Okay, let's go down now. Same speed. Okay, so we're going down. Yep, thank you. Okay.
Then at what heading are we going down now?
We're going down at 30, almost 308, 307.
Okay.
So this was a little too fast. Okay, that's good. So we went about 40 degrees. Can you center it up a little bit, just as you're going down a little bit more? Just lateral. Yeah, that's good. Okay. You're going down, right? Okay. Little too fast.
Yes, that's a little too fast. Now it's fine.
Yeah, this is good. That's good for down speed. You're down at the bottom? Okay. All right, let's do another 40 degrees. Okay, so that was the end of that transect. I would stop it there, Mario. Yeah. So it's 250. Okay, so yeah, you're gonna lateral over, right? Okay. Yeah, we're having some issues with the cable pulling us. Okay. Sorry. So where are we? We're at 265. Okay. Okay, I think that's there, 270. You can settle on 270. Let's do that. Okay, so 270, if you could just lateral over and center the chimney in the middle of the image. And are we pretty much down as far as we could get without smashing stuff? Okay. All right. Okay, so we're ready to go up. Oh, you think you could come down a little bit more? Okay. Yeah, yeah, absolutely.
Ah, that's perfect.
Yeah, okay, that's good. Okay, we're ready to go up. 270 is the heading. And we're ready to go up. Okay, all right. Yes. A little too fast. Sorry. So make a note, please, that this is the chimney, the extinct chimney that has bacteria on the top that is directly over the arms, one of Nicole's arms panels, and the larval trap. Okay. Okay, that's good for up. Okay, let's do another 40. So 230. Yep. We're settling up on 230 as far as the heading is concerned. That looks good, Mario. Yep, that's great. Okay. Looks good. Are we ready for the next one, you guys? Yep. Yeah, 230. Okay, we're doing the next traverse down. Okay. A little slower. Tiny bit slower. Yeah, that's good. That's good. You can go a little bit faster. So on this heading of 230, we're looking directly at the other chimney that we just instrumented. That's great, Mario. That is great. I think that you probably should turn the down camera off because we're getting flashes in the bottom. I don't want it to disturb that. So we're make a note. We're turning the down camera, the camera off. Okay, we're at the bottom. That's good. Okay, another 30 degrees. So we're going to go to 200. Oh, we're doing 40. That's right. Sorry. Right. 190 we're going to. Okay, we're settled up on 190. You can see the arms experiment just to the left. And we're ready for the next traverse up. Yeah, let's go up. At the end of this traverse, we're going to break the file. Okay, so just remind me when we get to the top. We'll stop and then restart. Do you need to get a little closer or not?
No, it's fine.
It's okay. All right.
Yeah, actually, because we are doing bigger jumps in terms of orientation, it's good to be a little bit far back because that will have more overlap between the transects.
Yeah, okay. Okay, that looks good. So let's just hold it there. Just hold it for a second. Natalia. We'd like to break the 4K file. So stop it, and then start a new one right away, okay? And then just let us know when it's started. It started? Okay, all right. Mario, you're free to go. So another 40 degrees to 150. Almost to 150. Okay. Mario's going to settle up and center it for us. Great job, Mario. Thank you. That looks good. Okay. You guys ready to go down? Yeah. And it's running. Natalia, it's running. Yeah. Okay. All right. We're ready to go down. Thank you. Oh, sorry. Yeah, no. I thought that we had sent it around. All right. Hey, Ross, are you online?
Yeah, I'm here.
Yeah, you need to be sure when you send around the Zoom link to send it to the NDSF folks, especially to Tito, so we can send it around to the teams out here. Okay, so let's remember the next time.
You mean the YouTube
yes,
link?
the YouTube link. Yes, please. Yes. Did you get that?
Yeah, copy that.
Okay, thank you. Appreciate it. The bio dives, we need to make sure that Lauren and Ken Costell do it, and I will send them a message today. But that's good. You guys all set? We're still recording, and we're down at the bottom. And let's go another 40 to 110. Thank you. So yeah, I'll okay. Okay, getting settled on close to 110, 111. Yeah, this is fine. We're good. You all guys all set? We're going to go back up. Okay, we're going up. Next transect up. Little tiny bit slower. Excellent, Ariel. Thank you. This is great. Just a little bit further up. Just get the top of it in the middle of the screen. Okay, that looks good. That's good for up. Okay. Another 40. So we're going to about, what, 70, right? Okay. 4K still on. Okay, we're just settling out on 070 heading. That looks good whenever you're ready. Okay, let's go down. Start the down. Thanks, Charlie. Still going down. A little bit further to go. That's close to being it. Okay, we're there. All right, let's lateral over. Let's go to 035, and yeah, and then we'll do the last one back to 000. Yeah, we're getting there. Does it really have to be exactly at 10:15 rather than 10:30? What's that? Uh, 035. Right. That looks good. Okay, we're going back up. Yep. Go a little bit faster. Okay, that's good. All right, let's go now to 000. All right, we're just settling out on heading due north. Looks good. Going down whenever you're ready, Mario. Okay, down. Starting the last one. Down, okay. Almost the bottom. Okay. Tito, I'd like 5 minutes to be able to do a turn around it as far as we can get, because it's important to tie it. Okay, Mario, when you're at the bottom, can you now spin right here at this depth level, 360 around it? Yeah. Is that doable? From this distance, just to spin around it, and you can go pretty quickly. No, leave it. About 6 meters, 8 meters.
And then there's no need to maintain depth. So if it bounces up and down while doing 360,
Yeah, that's okay.
It's okay.
No, but he can maintain the depth pretty easily, but it doesn't matter if it, bounces around, Mario. So just key is to just be able to go around the whole thing in one pass. That'll help tie the up and down lines. So it's fine if you're going up and down. That's perfect. You don't have to worry about it. Yeah, this is great. And we're about 6 meters altitude right now that he's maintaining as he's doing this this pan around. Everything's still going, right? So you got the start of this horizontal pan at 6 meters. Okay, he's coming around. He's not quite halfway around, almost. There you can see in the distance the sort of lineament that heads up parallel to the axial trough wall. That's got all the white staining and the logger in the distance on one of the chimneys. We're just heading passing 080 now. So vehicle is heading south, and we're coming around. Could go a little faster if you want, Mario. Okay, we've got just a little over 90 degrees to go. We're at 270. So now we're facing west. We're heading west right now. So we're looking at the east side of the structure. Maintaining a depth of about 2504 as we're doing this the pan around the midsection of the midsection base, I would say, of the structure. Got another 20 degrees to go.
Can go backward a little bit if you want, because it's coming out.
Can you go back a little bit? We're just losing a little bit of it in the side there. There you go. That's great. Perfect. Yeah. And we're coming around. Okay, that's it. We have to stop this now, and we got to give the vehicle over to the team so that they can recover, okay? Because we need to get back on deck. No, leave it on while he's going up.
Thanks, Dan.
Yeah.
And thanks to the pilots.
Okay. Oh,
Yeah,
okay.
thank you.
Thank you very much. Thank you, Tito. All right, the vehicle is yours to bring to the surface. Once we clear it, you can stop the 4K. All right. All right. Good. You can stop the 4K. Thanks.